In this lecture, we'll talk about the introduction of Iptables. Iptables is the interface to NetFilter, which are basically hooks in the Linux operating system that allows us to handle the packets going through the Linux operating system. It's a framework that allows network operations to be implemented by handlers. So those handlers offer packet filtering, network address translation, port address translation, directing packets through the network, prohibiting packets from reaching sensitive locations, and it's very powerful as far as what you can do on the Linux operating system to protect your Linux operating system and to route traffic through it, and can have it act as a router or a host, or have it act not just as a host, you can have it act as a router too. So those hooks inside the Linux operating system represents control points that allows specific kernel modules to register callback functions with the kernel networking stack. The function applied to traffic can do filtering, modification of the packet, and we will see the different filtering points and different modification points. And this is basically called for every packet that traverses the respective hook within the networking stack. So the hooks are called chains, and basically they separate packet operations into multiple parts based on where's the packet in the processing order. And each part connects to the NetFilter hook at different point to access packets. Those are called chains. So the chains, basically, you have a chain when the traffic comes into the host. Basically, this is a pre-routing, basically on preparing the packet and looking at its content and making a decision whether this packet is intended to the operating system itself. If it is, then it's going to get processed by the input hook or the input chain. If this packet is intended for a different host, then it's going to get forwarded by the forward chain. And once it gets processed and forwarded, it's going to get processed by the post-routing chain. If the packet is intended for the host itself, then it's going to get processed by the input chain. The host will reply. This will get addressed by the output chain and then the post-routing chain. It depends on where the packet is going to and where's the packet going to, really. If it's intended for to the host itself, this is going to be addressed by the input chain. If it's a response from the host to a packet that was requested, then it's going to get handled by the output chain. If it's an initiated by the local process, not a response to a packet, then it's going to get forwarded by the output chain. And as it returns, it's going to get forwarded by the input chain. So our focus in this class is to basically focus on the input and output chain. We're not going to look at the forwarding chain. This is for my new class that talks about the routing functionality of Linux. Our purpose in this class is to focus on securing the host itself from attacks. And we're going to see what are the different things we can do as it relates to the packets incoming to the host and outgoing from the host, including NATing, network address translation, including filtering, including a lot of the features that allows you to really protect that host from attacks. So what are the Iptables? So we saw the chains, right? Those are the hooks where it calls back the kernel for NetFilter functions. Inside each of the chain, you can have multiple tables, and it depends on what chain it is. The Iptables, there's like 5 main tables. The raw table basically is used to exempt the packet from connection tracking. And then you have the filter table. This is basically your basic filtering, basic firewalling function. And then you have the network address translation that's used obviously for network address translation. And then you have the mangle, which allows you to rewrite the packet headers, changing QoS, maybe mark down a QoS value on a packet if it doesn't meet your specific criteria, and so on. And then your security table. This is used to integrate with mandatory access controlled like SE Linux, and it's not covered in this class. let's take a look at how the packet gets processed and by which chain and tables. Basically, as the packet gets received, it's going to get processed initially by the raw table to determine if you want to basically bypass the connection tracking functionality. If you don't bypass the connection tracking functionality, it's going to be stateful tracked connection. And then next thing is gonna look at this basically on the pre-routing stage. This basically packet gets received and it's gonna look at it to determine where it's going. The first thing it's gonna take a look at is whether this connection, if you are making an exclusion in the raw table, then you might not be tracking that connection using connection tracking. Mangle, if you want to rewrite the headers, and then NAT, if you want to do NAT operation to route the packet differently. And then it's going to make a routing decision. Now that the NAT was done, now it's going to determine, okay, where's this packet really going? Is it going to the host itself, or is it going to a different NIC card on the host itself, if the host is acting as a router? And we're not going to cover this piece here in this class, but we're going to cover this piece. If it's intended to the host itself, then it's going to look at the mangle table, whether it's want to rewrite the headers. If there is something there, it's going to execute it, and then it's going to go through the filtering table in the input chain and determine, okay, is this, let's say this traffic is coming port 22, am I filtering port 22? And if it makes it basically a decision based on what I have in my filtering table, and then finally it's going to get to the local process itself. The local process would respond. As it responds and the packet leaves out from the box, it's going to get processed by the output chain. The output chain has multiple tables. It has the raw table, whether the connection needs to be tracked or not. And this is not only for responses to packet. If the packet was initiated by the local process, then it's going to go through the raw table, mangle table to rewrite the headers, NAT table to change the destination of the packet, and then filter table to determine if this packet should be allowed or not. Once that's done, then it's going to take a look and see which interface. If, for example, you have multiple interfaces, maybe the NAT change the destination NAT to a different interface, and it might egress to a different interface. But that's not a scenario we're going to cover here, because Linux as a routing host is so powerful. We're going to have dedicated class for it. This class is dedicated for the host itself. So basically, we're going to focus on, okay, if my host is responding to requests, if my host is initiating requests. So basically, the input chain, the pre-routing input chain, output chain, and then once the packet egress out the interface, is going to get handled by the mangle. By the post-routing chain, it's going to look at the mangle table and the NAT post-routing table. Just a quick preview on the forwarding. If my host is acting as a router and I'm going to be forwarding the packet across from one interface to another, I received it to one interface, I'm going to send it out another interface that's going to process by the forward chain, which has two tables, the mangle table and the filter table. So we'll talk more in the next lecture. Okay, in this lecture we will start by just creating an image for ourselves to use to test IP tables and learn about it. The first thing we need to have in place is the EVE-NG. And the EVE-NG machine is a virtual machine that allows you to run a lab environment in a GUI format. If you don't have EVE-NG, you can basically go to Google and do a search on EVE-NG. And there's a free and there's a paid version. You can get the community version, which is free. In order for you to download it, you can either download an OVA that's pre-built, or you can download an ISO and set up the VM using ISO. I prefer using ISO because that basically allows me to customize my disk space and the image itself. It's really up to you. It's not in the scope of our class to show you how to set up EVNG. I would recommend that if you need to have more details about how to install EVNG, go to YouTube, and EVNG have a channel where they show you a lot of details. They have a lot of videos available showing you how to set up the EVNG environment, and there's a lot of videos here, so you're more than welcome to just go there. Also, there's a good live help desk. There's a help desk that you can use to chat about your issue if you have an issue installing, but it should be pretty straightforward, right? And then once you install you can install the community edition, or you can install the pro edition. The pro edition has additional features which allows you to connect and disconnect interfaces without requiring to restart your lab, which is pretty nice, but it's not really a requirement for this class. You can use the community edition, which is fine. However, I'm not covering how to do the EVNG installation because it's really not in my scope. So once you have the EVNG VM installed, we need to download the Ubuntu 16.04 ISO. And basically we go to our handy dandy Google and do Ubuntu 16.04 download. Search for download. So we're going to use Ubuntu 16.04 TLS Xenial. Find the server ISO file, and then basically right click and choose copy link location, and then SSH into your VM, log in to your EVNG machine, and then go to cd opt unitlab add-ons QEMU and create yourself a folder. Call it like Linux RTR, and then cd to that folder, and then wget, and then paste your file. Basically that should download the image, the ISO file. Once it's finished downloaded, it should be here. I already have it downloaded, so I'm not going to go through the entire download. You basically move to file cd-rom.iso, and that's now you just rename it cd-rom.iso, and then you need to create an image file, QEMU image, create -f qcow2, and then the file name is hda.qcow2, and then 10 gig. It's not going to create a 10 gig file, it's just basically creating a small file, 193K. That basically is all you need to get you started creating the image. For me, I'm gonna copy the ISO, the correct ISO here. And once you finish with those two steps, you need to run the fix permission command. That basically corrects the permissions so that you can see that option of that node in your node list. So I'm gonna run that command, and now go to your EVNG machine and then create a new lab. So we're gonna create a lab. I'm gonna call this you can call it whatever name. I'm gonna call it Linux Iptables. And then I'm gonna add a network and then connect it to the management cloud. If you have EVNG Pro and you don't have your network set up in a way where you have reachability to that VM, you can use the NAT option, but that's not available in the community free edition. It's available in the Pro edition. We go to management cloud, create the network connectivity management cloud, and then we're gonna click on node and go to Linux, and then we're gonna choose the one that we created, which is Linux RTR. Okay, and you can use the default, that's fine here. Save, and then we're going to connect it to the network, this way we can download the software, and then we're going to start. Open it up. We're going to go through the setup, English, hit install Ubuntu server, hit enter on that. You can use your keyboard, your language. We're going to step through the installation here. If you have your network set up correctly, it should pick up an IP address. We're going to call this Linux RTR and hit enter. Username, I'm going to choose username Ubuntu, password Ubuntu, weak password allow, yes, encrypt home directory, no. You know, choose your time zone, it's fine. And then I'm going to use guided, use entire disk. And then write changes to disk, yes. If you're going through an HTTP proxy, you can put this information, otherwise click continue, hit continue. I'm gonna choose personally no automatic update, that's fine. And then once you get the options, we're gonna basically install OpenSSH server, scroll down to OpenSSH server and then hit the space bar and then hit continue. And this is asking you to install the master boot tracker, choose yes. Hit enter on that. And then it's doing the final steps of updating the boot image. I hit continue on that. And then we're just gonna stop the machine. And then what we're gonna do right now is go to the folder where we created the image file. And then we're gonna delete the ISO, rm cd-rom.iso. And then we're gonna boot it up again. Then we're gonna do some changes so we can basically create our base image for our labs. Booting up right now. Okay, so the 1604 gives device names for the network interfaces. We're gonna use change the setup to use the ETH0, ETH1, and so on. So basically we need to modify the grub bootloader to allow for those options. So we're gonna do sudo vim etc default grub, put the root password, the Ubuntu password, and then under grub cmd line we're gonna hit insert, and then we're gonna type in by net.if names equals 0, and then BIOS dev name equals 0. And then we're gonna also add an option to enable the serial console port. And here we're gonna add console equal tty s0, 115,200, the baud rate. Console equal TTY S0. And so basically that enables the interface name, disable interface names, and disables BIOS dev names, and enable the console. We're gonna write quit, and then we're gonna do enable the TTY S0. Well, first we're gonna update grub, sudo update dash grub, and then once that's updated, we are going to reboot. Sudo reboot. And then once it reboots, we're gonna enable the serial console. Okay, login, and then sudo system control systemctl enable serial getty at TTY S0.service. This enables the console. Okay, and then we're gonna install additional software. We're gonna do sudo apt install quagga. Well, first we're gonna do sudo apt update. So update the repositories. vi etc. So right now it doesn't have an IP address ifconfig h0 because I renamed the h0. So I'm gonna set up an IP address really here. Ifconfig h0 192.168.101.99 mask 255.255.255.0 gateway 192.168.101.1. I'm basically setting up manual IP. I need to do sudo h0 192.168.101.99 net mask 255.255.255.0 gateway 192.168.101.1. Let me do sudo ifconfig h0. Oh, it's set up. That's weird. Route route add default gateway 192.168.101.1 sudo. Okay, vi etc resolve.conf, and then we're gonna add name servers 8.8.8.8 edited as sudo. At the end here, hit insert name server 8.8.8.8. Right, quit, and then I'm going to do sudo apt update, sudo apt install. Well, let's do the upgrade. So this way I have the latest upgrade. So let it do the upgrade, choose yes. Then you do the upgrade. We're basically fixing and tweaking our image to make it fit our need. Okay, now we're gonna install additional software. We're gonna do sudo apt install quagga. This is the routing daemon that allows you to do RIP OSPF. So that's good. And now we're gonna shut down -h now. So basically now we created our image, and then we need to basically close out the lab, and then we're gonna click on the lab here. We'll see you see here the UUID. This is the folder where the image file is created. So we're gonna go to cd opt unit lab, and then temp, and then the folder. Oh, cd opt unit lab, and then the folder temp, and then the folder which is 3 begins by first 0, and then the UUID is 309. That's the UUID right there. And then we have only one image, one file, so that's fine. And then should have HDA QCOW2 here. So let's cd to that folder. This is where the image that we created got basically created with all the features we need. And then what we need to do is convert it to QCOW2. Convert -c-o QCOW2 HDA.QCOW2, and we're going to copy it to temp HDA.QCOW2. QEMU image, and then convert. So now it's converting it to QCOW2. Okay, so it finished converting. We're going to go to our folder under unit lab, add-ons, QEMU, Linux, RTR. And then we're going to cp temp HDA.QCOW2 here. Okay, so that basically copied the file. So I don't think you need to run fixed permissions again, but we're just gonna run it just to be on the safe side. And then let's open up the folder. Or basically I ran fixed permissions one more time just to be on the safe side. So I'm gonna create another image just to make sure it works correctly. It has all the features. We're gonna go here, Linux RTR. That's creating a new instance. We're gonna give it a different name. Save it. Connect it to each 0. And then start it. Just to make sure everything looks good there. Okay. Okay, I'm getting a login prompt. And if I do if config each0, it's there. We haven't configured all the other components, but yep, so this is basically our image that we're going to use in this class. We'll talk more in the next lecture. So just to kind of get a clearer picture, so the Linux kernel has hooks, okay, and those hooks are called chains, right? So those hooks is when the packet traverses the Linux box, it goes through different hooks. So once the packet arrives, the first hook that will get processed is the pre-routing hook or the chain. And then if the packet is determined to be coming into the box itself, it's going to go through the input hook or the input chain. If it's determined that the traffic or the packet is destined to a different destination that's routed through the box, a routing decision will be made. So here is a routing decision. And then the forward hook will be used, or the forward chain. Once the packet gets determined to needs to be routed through the box, it will get processed by the forward hook or the forward chain, and then it's going to get processed by the post routing chain. Okay, if the packet is initiated by the box itself and it goes to the exits out one of the interfaces, it's going to get processed by the output hook and then the post routing chain. Yeah, so basically those are called the net filter hooks or chains. Net filter hooks or chains. So it depends on how the packet gets processed. There's different chains that gets used, and within each chain there is different tables that gets processed. So the most simple table is the filter table. The filter table, the default table, is used to make decision about whether to let the packet continue or basically drop it or deny its request. It's kind of like the basic firewall. And then you have the net table. And the net table is used to implement network address translation. A packet that's entered the network stack, the rules in this table will determine whether to modify or how to modify the packet for source or destination address translation in order to basically impact the way that the packet and any response traffics are routed. This is often used to route packets to networks when direct access is not possible. So for example, if you have internal network with RFC 1918 and you want to route it to the internet. And then you have the mangle table. The mangle table is used to alter the IP header of the packet. It could change different characteristics of the packet, like TTL, increasing TTL, reducing TTLs, changing the QoS, marking the packet for further processing down the IP table chains, and so on. And then you have the raw table. So the raw table, it's IP tables is stateful, meaning the packets are evaluated in regards to their relation to a previous packet. The connection tracking feature built on top of the net filter allow IP table to view packet as part of an ongoing connection or session instead of a stream of discrete unrelated packet. The connection tracking logic is usually applied very soon after the packet hits the network interface. The raw table has a very narrow defined function. Its only purpose is to provide the mechanism of marking the packet in order to opt out. So basically opt out of the tracking or the statefulness of the IP tables. Okay, and then you have the security table. The security table is basically used to integrate with SE Linux, determine if some programs can be allowed to. It's different from the filter table. The filter table is basically to filter the packet based on whatever criteria you specify. The security table is used to integrate with SE Linux. So the big question is how things get processed, basically. So we looked at what chains or hooks are in the Linux kernel to give you the ability of controlling the traffic. And there's the different hooks, the pre-routing, the input, the forward, the output, and post-routing and output. So where does the table, so here, this is called the chains or hooks, and this is the tables. Okay, so this is to show what exactly happens to the packet when it gets to the box, if it's intended to the local box itself. So the first thing that happens is when the packet gets received inbound, it gets processed by the raw table. And like we mentioned, the raw table is basically used to determine if this is going to be tracked by connection tracking or not. You can basically bypass connection tracking in this table itself. Okay, if this is allowed without having anything on the raw table, it's going to register a connection state, whether it's since in act, established, or so on. And then now that the mangle table will take effect. So the mangle table basically is going to determine if you want to rewrite the header or rewrite the IP, the QoS information, and so on. And then it's going to get processed by the NAT pre-routing table. The NAT and the pre-routing table. So let's say maybe you have a box that receives TCP session on port 25, but you want to pre-route it and send it to port 2025 or something like that. So that's where this is going to happen. And then once pre-routing is done, it's going to determine what traffic is going to. Is this destined to the local host? Yes or no? Based on the NAT pre-routing, that will determine if it's coming into the local host or no. And if it is going into the local host, it's gonna basically get processed by the IP table, the mangle in the input chain. The mangle input chain will also can be used to reroute the packet. So there's actually hooks in every step of the way, which gives you a lot of flexibility. And then finally, it's gonna basically get filtered based on this, just the filter rules. The host response. Once the host responds, it's gonna get checked against the raw output, and then a connection, it's gonna register the connection. If there is a connection, let's say if this is locally initiated, it's not a response to an existing session, it's gonna register a connection. If it's a response to an existing session, it's gonna check the connection state to determine if this is a response to an existing connection. If it is, then it's gonna process it against the mangle table, which basically can rewrite the headers and so on. And then it's gonna check the NAT table, the output NAT table. If there's any, and this is basically applies if the packet is gonna get sent out by the box. And then it's gonna decide how to route the packet, and it's gonna filter it. And the filtering on the output basically would filter the traffic, see if it's allowed or not. And basically here you can say if this is a response to the existing session, allow it. And then it can do the mangle again, rewrite the header if needed, and then it does the post routing NAT. And then it's gonna exit out the application. So this is basically a lot of steps, and what I would like to show you is how this is done. We'll talk about this more in the next lecture. So the IP tables, we looked at the chains, and basically the hooks were basically the tables gets evaluated. And a bit table means a rule set. It's a list of rules that you specify. And once that table gets processed, it's processed sequentially. And the first match, once a rule matches, basically what happens is the -J or the jump action or the target specify what to do with the packet. So -J could mean jump to a different chain, and a different chain, you can create your own custom chain that makes the IP tables or the rule set easier to read. Or the jump could mean execute an action or target. The common targets are, the two basic targets are accept, which basically accept the packet. However, even though you accept it, it doesn't mean that this packet doesn't get dropped at a different table in a different chain. Or you drop the packet. Jump means go to a different custom chain, basically. So jump, the -J means a target, whether it is go to a different chain or take an action. There are many targets. The ones that we'll cover in this class are, other than drop and accept, are destination NAT, log, no track, return, and SNAT. DNAT and SNAT are for source and destination NAT. Log is for logging. No track is to bypass the connection tracking. And a return basically is to return back from the calling chain, from the existing chain to the calling chain, the chain that originally called the packet. So basically, in the previous lecture, we talked about the packet going in through different chains, the pre-routing, input, and forward, and output, and post routing. There are tables or control points in each of those chains. Depends on which chain we're in, different packets apply. For example, pre-routing, you have the raw table, you have the mangle table, and then you have the NAT table. Input, you have mangle filter table. Output, you have the raw table, mangle table, NAT table, and filter table. And then post routing has the mangle and NAT. So each hook of the Linux kernel processes through the different tables in order like we discussed in the previous lecture. But then once it hit the table is nothing more than a list of rules. And the first match of this rule, like in any firewall and any access list, it will basically apply the target action. And the basic targets are accept or drop. And we look at other, and then we have source NAT, destination NAT, that applies in the NAT tables. And then we have return, we have reject, and we have no track. And those are the tables that we're going to process. So basically that's not a single point, single stop. We have the filter table here. So basically maybe when the packet comes in, it gets processed by the NAT table, and then after that it's going to get processed by the filter table, and then it gets processed, and then as the response goes out, it's going to get processed by the other tables in the chain until the packet exit the box. So each table has its own list of rules. So if this one of the tables finish processing, the next chain and next table would take next actions in the next table. So it's not just if I hit the match the NAT table, then that stops processing. No, even though if it's although if it's dropped, then that's fine, it's gonna get dropped there. But if it's not dropped, if it's accept, this is gonna get basically also still processed across the other chains and tables until it gets to a destination. That's what happens to the packet. Then we're going to look at the different examples and look at the different tables as we progress to this class. So in this lecture we will set up a new instance in EVE-NG, create a new lab, and then basically we're going to add first the network, and this is a new fresh setup. This way we can, the previous one we used for the image itself, now this one is going to be for our setup. So we're going to add a network, the management cloud network, and we're going to add the Linux instance. The Linux instance is Linux RTR that we created. And we're going to connect it to the network. And then we're going to do the initial setup, which basically we're going to configure the IP address and set up the standard configuration. We're going to install Apache 2 so we can test the input and output chain and NAT chains and other input and output chains and the filter tables, and then we're going to test the NAT, and we're going to test a lot of stuff we talked about in the previous couple of lectures. The first step we have to do login and basically sudo su so we can have root privileges, and then vi etc network interfaces. You can use any other utility like nano, whatever you're more familiar with. Auto eth0, we configured eth0 as our first interface. We removed dev names and BIOS dev names. Interface Ethernet 0 and net static. Address 192, you can use your own address, right? Depending on how your network is set up. Net mask 255.255.255.0. And this is misspelled. Gateway, the gateway that you have. And then DNS name server 8.8.8.8, and then right quit, and then apt service network and restart. So the interface IP addresses with deck effect. I think a DNS name server, not servers. Column, insert so I can edit. And service network and restart. Address net mask gateway. If config. Interface inet static. And restart. If config. Apt update to update the configuration, the packages, and then we're gonna do apt install, and we're gonna install Iptables persistent. This will allow us to save Iptables across reboots. So apt install Iptables persistent. Apt install Iptables persistent. Here it asks us if you want to save, use the Iptables be saved in ITSI Iptables root.v4. That's default. Yes on those two. And then we're gonna install Apache 2, apt install Apache 2. Yes. And once it finishes installing, I should be able to access Apache 2 through still signing up. So now I'm able to access Apache 2. So now if I do like iptables-mvl, this is by default when you don't specify anything, it's showing you the filter tables. And the filter tables exist in the input, forward, and output chain. And if I want to specify a different table like nat to tnat-mvl, will show me the net tables, and the net tables exist in the pre-routing chain, input chain, output chain, and post-routing chain. Mangle, table mangle. This table mangle is in the pre-routing, input, forward, output, and post-routing chain. And then raw exists in pre-routing and output. And then security exists in input, forward, and output. So again, give us an idea on how to get our lab set up, and then we'll talk more in the next lecture. So in this lecture, we will modify the, we will do some initial testing. We will modify the console connection to be serial. This will allow us to connect to the port from the serial console, and this basically is more lightweight compared to the VNC, QEMU, RDP type client, which is more a thick client. I prefer to use the console itself. So I restarted the VM, and if I let it, basically I'll have to wait for a little bit until the serial port starts. And then once the serial port starts, you will see output in the console. And then now, once we finish installing this, we'll see like an example on packet filtering using the input and output chain, and look at the connection tracking and all the other stuff. So now that this box started up, I'm going to basically log in, and I'm going to show you kind of an example first here. If I try to connect to the web server, I'm going to be able to, of course, because there's nothing that blocks me. So if I do iptables dash append, and I'm going to append to the input table, I'm going to append specifying the protocol TCP port 80 allow, and then destination protocol TCP destination port 80, and then I'm going to specify to J accept, and input iptables dash a output dash p TCP dash dash a source port 80 dash J accept. Basically what I'm setting up right now here is a filter that is not stateful. And the reason why it's not stateful is I'm not triggering the module connection tracking, and we're going to see what the module does. But basically what I'm doing right now is I'm specifying to allow this is the host here in the middle, and then traffic incoming to destination port 80 will be allowed, traffic leaving the box sourcing from port 80 will be allowed. So just let me refresh the screen here. If I do iptables-mvl, let me refresh the screen. iptables-mvl. Okay, I see here 8 packets. If I refresh the screen, I see more packets here. Now I'm going to install another software called connection tracking. Install contract. And then basically that shows me the connection statefulness of the iptables. So if I do contract-L, I see nothing. I see no sessions. And the reason why is I'm not triggering the module of connection tracking, which allows me to track connection, have the statefulness piece of the iptables functionality. So to do that, we're going to have to trigger a module. And there's different modules that exist in iptables. If you go to Google, we'll see a whole bunch of modules, extensions, and so there's a whole bunch of extensions here. Match extensions. So those are the matching type extensions, and there is different extensions that achieve different things. Some of the notable ones are we're going to discuss are connection tracking. This module, when combined with connection tracking, allow access to the connection tracking state for this packet or connection. So hash limit, we're going to look at hash limit and how to limit the traffic or do bandwidth throttling. We're going to look at that. This ICMP specific helper, it specifies ICMP type, like matches based on ICMP type. IP range matches based on IP range. So this is a module, another module. IPVS length matches on length. Limit, this module matches the limit rate using a token bucket filter. This is kind of a QoS throttling as well. Multi-port, this allows me to specify multiple ports. So if I specify M multi-port, I can specify source ports and destination ports. And this could be in the range of port through port. So there is a lot of modules, extensions that allows you to expand the iptables and use a lot of features in iptables. And we're going to see over the course of those lectures what and this one is notable here. OSF is the list of the OSF module does passive operating system fingerprinting, and basically this is pretty interesting. So let's see what we talk about when we talk about connection tracking. So there is a connection state, and this connection tracking allows you to track different state of the connection. So if we have traffic that is incoming, let's say the host is a web server, and this web server receives traffic from different hosts. So this web server is listening on port 80. When a client connects to the host, the first basically is SYN, and then SYN ACK, and then ACK, and then the transfer of data across, and then the close of the connection, close or reset and reset. So that stage here is called new connection. So this is a new connection, and this is established. And the SYN ACK, the SYN is basically considered a new connection. SYN ACK and ACK are related because still the connection hasn't been established yet. If I want to basically, and I have a web server and I want to restrict, that I only will be able to receive connections to this host that is new, related, or established. At the input side, okay. At the output side, basically the only applicable is not new, because so here traffic is going to destination port 80. Here traffic is going from source port 80. So to make my web server not initiate any connection on port 80 or restrict it to just respond to client sessions, and this side I'm going to specify new, related, and established, and on this side I'm going to specify related and established. So that makes it stateful, and we're going to see this when we change our configuration. We're going to see state of the connection. So let's go ahead and go to the box here, and then we're going to basically iptables dash flush input, basically flushes all the tables, tables dash f input, iptables dash f flush output, iptables dash nvl. There's nothing in my rules, so if I specify iptables dash I insert an input, that puts it up top. Protocol TCP dash dash destination port 80, that's in my input direction, dash m contract, and then dash CT state new, related, established. I'm going to accept that. And then iptables dash I output dash protocol TCP dash dash source port. Now it's in the reverse direction contract. I'm just going to allow CT state related and established. That's going to make this stateful. So to prove it, let me just deny everything else afterwards, any TCP. This is going to be A-A is append to the input. That means put it at the bottom of the chain. And I'm going to specify protocol TCP dash J drop. And then output if it's protocol TCP, I'm gonna drop. So if I refresh, I'm able to refresh. If I refresh my Apache connection, I'm able to refresh. But now if I do connection tracking -L, I see an established connection. And if this is basically an established connection between my client and the server. And if you look at the source port, destination port, the reverse is going to be destination port, source port. And if I do iptables -mvl, I'm allowing the client to establish a connection. This is the input chain. I see 11 packets and 1247 bytes. And then the output direction, I see 11 packets and 1247 bytes. Now, because I dropped everything after the output chain, now my box is restricted to just being a web server, nothing else. It cannot even establish a connection to the outside. To prove it, if I try to SSH into it, it's not going to allow me, because the reason why at the input chain, I'm basically accepting just connection to port 80, and I'm dropping everything else. That basically kind of shows you a state of the connection. So right now, if I want to try the multi-port destination extension, see multi-port, and instead of just being, I can save it here, iptables -save, and then pipe it to or output it to etc iptables rules.v4. That will make it persistent. Now, instead of editing the iptables from CLI, I can edit it from the file itself. Let me use nano etc iptables rules.v4, and I can make it not only this mtcp, I'm gonna make it mtcp-m multiport destination ports 22 and 80, so I can allow 22 as well. And then here also I'm gonna specify -m multiport destination source port, or you can make it abbreviated to S ports. So let's make it S ports 22. Now it's 22 and 80, right? Now I saved it in the Control X and then save. Yes. I saved it in the file. I can basically use iptables-restore and redirect the etc iptables rules.v4 to it. Now I have the iptables-mvl. I have multiple ports allowed, not only port 80, I have port 22 and 80. And here I'm gonna try to SSH now, and I'm able to SSH. So basically that allows the connection. So I used two extensions. I used the multi-port extension, and I used the connection tracking. And if I do connection tracking now, -L, I see the connection to port 22. And if I do refresh here, I should see also the connection to port 80. I see here two connections now. Let's continue more in the next lecture. So now in the case of restricting a host, so the purpose of this class is to kind of focus on host hardening as far as iptable is concerned. So let's say I have a host, and the host purpose is to be a web server only. So what does this web server need? It needs port 80 like we saw the last time. It needs maybe SSH port 22, and other than that, basically this is input direction. And I should basically be allowing new, established, and related. And also, on the reverse direction, I should be allowing, basically this is destination port here, source destination port. On the source port side, I'm going to be allowing port 80, traffic sourcing for port 80 or 22 that basically has the related and established. So what else do I need to restrict this host? I need to be able to update that host, and this requires the host to be able to establish new session to destination port 80 and 443. This is on the output direction, and this is going to be new, related, and established. This is protocol TCP. And then UDP, I would need to have destination port 53. And on the reverse direction, I need to allow related and established. And in this case, I'm going to specify the opposite direction, which is source port 80 443 TCP, source port 53 UDP, and those are related and established. And maybe I can allow ping as well, ICMP, for troubleshooting, ICMP allow it, and ICMP allow it. Maybe that's new, related, and established. And here is going to be basically related and established. So if I do this and then drop everything else on the input and then drop everything else on the output, this host will be just restricted to receiving requests on destination port 80 and 22, establishing outbound connection on port 80 and 443 for updates and things like that, and allow destination port 53 for DNS lookup, ICMP for troubleshooting, and then drop everything else. So let's do that. So here's my hosts, and I'm going to achieve this restart session. So right now, sudo su. If I want to do apt update, I'm able to. Well, I'm unable to, and the reason why is iptables-mvl. I denied all TCP traffic in the reverse direction on the input side. That means I'm unable to get traffic sourcing from port 80 and 443. So I'm gonna basically delete that entry. If you want to see the line numbers, you can do nvl-line numbers. You will see the line numbers. So this is line number 1, number 2. That's easy to see, but if you have hundreds of lines, then it makes sense to have it like that. So if I do iptables-d2 input and iptables-d output 2, I'm deleting line number 2. If I do iptable-mvl line numbers, I'll see only one line in input and one line in output. And basically right now I allowed source port traffic destined to port 22 and 80 for new related established, returning traffic related and established. Now I want to focus on the output direction, and I'm gonna, if I do apt update right now, I should be able to, because I removed that restriction. But now I want to restrict my host to just the ports that we discussed. So I'm going to do iptable-d append to my input. I'm going to append protocol TCP dash multiport dash multiport to use multiport dash dash m multiport dash d ports dash source ports 80443 dash j dash m contract dash ct state new this is going to be related and established dash j accept, and I want to ct state and misstep ct state, and then iptables dash a input dash b udp. I don't have multi-ports here, I have only a single port. I'm going to allow dash d port source port 53 dash m contract. This way I'm just basically allowing the return traffic for DNS, ct state related established dash j accept, iptables dash a input dash protocol ICMP dash I'm not gonna specify anything, but I'm gonna do dash m contract dash ct state related and established dash j accept, and at the end I'm gonna drop everything else dash a input dash j drop. And then on the output direction, iptables, we allowed the return traffic for port 22 and 80. We're going to append to the output dash ptcp dash m multiport dash d port 80 and 443 dash m contract dash ct state new related and established dash j accept, and then for DNS iptables dash a output dash p tcp dash udp dash m udp dash d port 53 and dash j dash m contract dash ct state new related established dash j accept ct state use d port, and then iptables dash a output dash protocol ICMP dash m contract dash ct state dash new related established dash j accept, and then I'm gonna drop everything else dash j drop. If I try to do apt update, I should be able to. And the reason why is I'm just allowing specifically what the host needs. And if I do want to do ping, I should be able to. And the reason why is I'm allowing this. If I do iptables dash nvl, I see here ICMP 2 packets. I see port 1556. I see the return traffic for server traffic for port 22 and 80. I see my request going on port 80 and 443, my request for port 53. I see those getting accepted. I see the return traffic for port traffic returning for port 8443. I see the UDP traffic for port 53 returning back. I see the ICMP returning back. If I do contract -L, I see the connection here is there in time wait. This one is about to get deleted. This is for port 80, and this is for port 22, and this is for port 53, and those are this is for where's the ICMP one? Let's do ICMP ping one more time. And we see here this is for the ICMP type 0 code 0, that's the echo, and we see those connection getting established. Now if I try to access anything else outside that, so let's try to access like SSH to anything port 2222, 192.168.101.1, port 2222. I'm not going to be able to. And if I do iptables-mvl, I see 2 getting dropped. But right now, it's getting dropped silently. I don't know what is getting dropped. So, and one thing to note here is I accept ICMP. We're accepting ICMP inbound with a related established, but we're not accepting new. So technically, I won't be able to ping that box because I don't have the new session allowed in my ICMP. So this makes my host invisible, really. It's going to only respond to port 22 and 80 TCP and nothing else. So that's kind of an example on how to restrict. Now if I want to save that, iptable-save, pipe it to itsy iptables rules.v4, and that should be saved and it will survive reboot. We'll talk more in the next lecture. Now in this lecture we'll talk about source NAT at the input. So this is another option that you can use, is do SNAT at the input. So at the input phase the pre-routing already happened, and the packet the source can be rewritten to a different IP. Use this to source NAT traffic before it hits the local process. So let's see how to do that. In this case, we're going to just change the IP address. For example, maybe there is a conflict between IP addresses that you're trying to overcome. You can do that. So we'll go ahead and source NAT my IP address 192.168.0.70 to be 192.168.0.170. So if we look at the IP tables now, this is going to be the TNAT table dash I input, or append because there's nothing on input, dash source 192.168.0.70 as this basically protocol TCP destination port 22 dash J SNAT dash 2 SNAT. The SNAT is 2 source 2 and 192.168.0.170. So now if I SSH into the box 101.200.22, if I look at the connection tracking -L, we'll see here that the local process itself sees my source as 192.168.0.170, not 0.70. So this could come handy if you want to hide an IP address from the input process, or change the IP address from input process. Maybe, for example, you're allowing all traffic in one net to be behind one IP address. If you have an overlap or any other things that of that nature, that you can use that to hide the source traffic. So in this lecture we will talk about doing destination net at the output. So far we've seen the destination net on the pre-routing, and the reason why there's destination net on pre-routing is, picture it like this: if your host is acting as a router, you can basically have the traffic coming in on your NIC card and going out a different NIC card, and the destination net will determine that to go out to different interface, because the destination net, the destination address and port will be written. In the case of our class, we're using it as a host only, so in that case we change the destination net, change the port, and then on the input side the packet has been already processed for the routing, destination routing technically. So now at the input level I can change the source, and changing the source would allow me to avoid overlapping network issues and things like that. If the host is initiating a new connection and going to the output direction, the source is going to always be the host IP. That's basically first stage of the traffic egressing. The host, the packet itself will have to be encapsulated and sent on the network. And this is the out phase, the output. So that's the output phase. At that phase you can do a destination net, and the destination net can determine where the packet is going, or if the port will be changed and so on. So at this stage we'll see the destination net. Going back to our example, if we recall, we allowed port 80443 for outbound, and we allowed TCP, and we allowed UDP port 53. If this is for new, related and established, and the inbound direction, corresponding packets that are sourced from source port 8443 in 53 UDP was allowed in just if it's related and established. So in our example, we're gonna do a destination NAT for port 22. So we're gonna say if the traffic is going out reaching TCP port 2222, I'm gonna destination NAT it to port 22. And you can be specific on which IP address to do that for, or you can do it for all IP addresses. So because I don't have port 22 allowed here, I need to add port 22 and then destination port 22, and on the input direction I need to add port 22 for source port. So let's see how to do that. So I am going to add iptables-t net append to the output. Let me clear the screen. Oops. iptables-t net -tnet-mvl. Let me delete what I have here. iptables-tnet-d output 1 2 1. So I'm gonna say iptables, anytime my host is trying to talk to port 22, I'm gonna forward redirect it or change the destination port to port 22. So tnet -append to the output chain, append any port, protocol TCP, destination port 2222, G dnet, destination NAT to port 22, column and 22. Oh, let me delete that. iptables-tnet-d output 1 22. So anytime traffic is going to port 2222, it's associated to port 2222, I'm gonna send it to port 22, and I'm gonna be specific. I'm gonna also add another port here, output to protocol TCP, destination port D port 2223 as another example. Destination IP 192.168.101, that's the one that I'm gonna try to SSH to. I'm gonna also do DNAT to 192.168.101.122. So now I have two examples, one for anything that's going to port 2222 and one that's going for specific port 2223. So if I do iptables-mvl, like I mentioned, we don't have 22 allowed in the incoming direction for a new, and outgoing direction for new, so I need to edit that. I can either, the easiest way to do it is to do it through the rules, edit the file, rules.v4. Before I do that, let me save. iptables, save. Let's see, iptables rules.v4, and make sure I have all my NAT tables. So I have destination NAT, and I have this two destination NAT at the output, destination NAT at the pre-routing. So I have everything saved. I'm gonna do nano, let's see, iptables rules.v4, and I want to allow port 22 on the outbound direction for new, related, and established, and then I need to allow port 22 right now, and the input port 22 is allowed for new, related, established, but I didn't have it allowed on the outbound direction for new, which means my host could not establish SSH or traffic on that port. So I'm gonna save that and restore it. Let's see, iptables rules.v4. If I do iptables-tnet-mvl, I have my destination NAT listed. So now I'm gonna try to SSH to port 2222. P 2222. So let's see why. Speed routing input regulated and established. We're gonna allow. I didn't have port 22 allowed. Let's see. Maybe you just need to add port 22. So I didn't have port 22 allowed in my incoming direction. So the connection tracking would take care of that, of rewriting the packet. So if I see here, I have 192.168.101.200 going to 101, port 2222. The return is from source port 22. So all I need to do is basically allow the return traffic for port 22. I didn't need to allow the traffic for port 2222 because the connection tracking will take care of that for me. So let's try to do port 2223. I see connection 2. So if I do contract -L, I see here the 22 port 2223. Where is port 2223? 23. Port 2223. Here it is. I see the connection got established. So that's an example of rewriting the packet destination. Destination IP, destination port when you do that. So we did an example for ports. Let's do for destination IP. So IP tables, let's add tnet-a output. I'm gonna specify if I'm trying to reach destination 100.100.100.100, I'm gonna basically do destination net to 192.168. 192.168.101.1. Okay, so now if I ping 192.168.101.1, that will be pinging my default gateway. If I do SSH, just to prove out 100.100.100.100. If I do if config is 0, I see I'm connected to ETH1. Actually, it is. I'm connected to my not 100 100. I'm connected to the host, my default gateway. So those are 3 different flavors of doing destination net at the output. So in this lecture, we will see how to do source net. So now the traffic got processed or got created by the hosts. In the case of our host-based IP tables, the traffic got created by the host and it sent outbound. I can change the source net. So let's say my IP address of my host is, well, right now my IP address is 192.168.101.200. But when I try to connect to port 22, I want to be netted behind 192.168.101.201. So that's doable, and you can do this with SourceNet. And let's take a look at the SourceNet. So iptables-mvl. Now iptables-dnet-mvl -tnet-mvl, and I want to be able to do this at the post routing. There's nothing in the post routing table right now, so I'm going to do iptable-tnet-a post routing, and then source protocol TCP. And in this case, it's going to be my source port, if my destination port. Destination port is 22. I want to be able to net behind the different IP address. So I'm going to do JSNet, that's source net, 192.168.101.201. Okay, so there is a challenge with that, and the challenge is I don't have any entries on my there's no ARPing that can be done on my host without having an IP address for that network. There's different ways of doing this. Like for example, if you wanna, you can point the traffic to your host, and it's gonna respond to it, but it still needs to connect. It needs to still respond to ARP. So in order for it to respond to ARP, we're gonna add an IP address to our network interfaces. Let's see, network interfaces, and we're gonna create an IP address auto E01 and face E01 inet static address 192.168.101.201 net mask 255.255.255.0. And if I restart my networking, now I should be able to be seen under 192.168.101.201. So let me SSH now to my default gateway. And I'm going to see netstat dash nt loop np. So I see my connection established, and it's coming from 192.168.101.201, and I was able to source NAT it, and I also was able to do that because I have the IP address on my network interfaces. So and then this way my host can send an ARP for this IP address or respond to ARP for this IP addresses. And if I do connection tracking -L, I should see that connection here. It's time wait. Here's the source. It's coming in. This is basically the packet as it's received from the network stack in the post routing chain. The source is 101.201, but as it exits out, or as the traffic return back, you see the source, which is in the reverse direction, will be destination, will be 101.201. So this is an example of doing source NAT at the post routing level. In this lecture, we'll look at the raw table. And Iptables is a stateful firewall. Well, sometimes you want to save the state connections tables for important sessions that really have state behind them. And packets that are stateless in natures like ICMP echo, echo reply, you want to basically bypass the connection table. That's where the Mangle table is used for. So if we look at where the raw table gets utilized, so on pre-routing, once the pre-routing basically decides whether the at this chain you have the raw table, and in the raw table you can specify the target action to no track. And this is where you can basically say, hey, I'm gonna treat this packet as non-stateful, and I'm just gonna be not tracking this packet. And then also, so this is basically the host right here. So I'm gonna specify that if my traffic is coming into no track, basically if I'm coming in as ICMP packet, I'm not gonna create a session for it. And then also I can do it at the output direction, the raw table. So as you can see, pre-routing, because this basically is where the session it gets initiated. So if my packet is coming in this direction and I want to make it non-stateful, I'm going to match it in the raw table in pre-routing. If the packet is leaving my host and I want to make it non-stateful, I'm going to match it in the output. Okay, so let's see how to do that. So the first thing we have to do is basically allow ICMP. We didn't allow ICMP. So we're going to go ahead and allow it in the filter table. So the filter table still will pass, the packet will pass through the filter table, but it's not going to be tracked by session. So we have to allow it. If I do iptables-mvl, my input tables does not have ICMP allowed, so I cannot ping that box. I need to allow it. So let's add it. I want to put it up top, this way it doesn't mess with my table, my logging. So I'm gonna insert it at the top, input, and then protocol ICMP, and I'm gonna specify ICMP type echo 0. Let's try ICMP type 0, and then I'm gonna basically J accept. So it's still no response because I need to allow it in the output direction. Iptables -a output -b ICMP. I want to put it up top. Insert. ICMP type. The response is ICMP type 8. J accept. So iptables, let's make sure I have the right ICMP type. Echo is 8. I flipped it, so I'm gonna delete that. So basically the deleted iptables, there's D input 1. That's gonna delete. Well, let's see it first. iptables-mvl input, it's line 1. So I'm gonna delete line 1. iptables -d input 1, and iptables -d output 1, and I'm gonna add it again with the correct. So echo is 8, echo reply is 0. So for input direction, I'm gonna specify ICMP type 8, and for the output direction, I'm gonna specify ICMP type 0. And now I should get a response. See, now it started responding. But if I look at here, connection tracking -L, I see those ICMP. And if you want to bypass this, you need to do it in the raw table. So let's do that in the raw tables. iptables -a because there's nothing in the pre-routing raw tables. -t raw, table raw. The chain is input pre-routing. There's protocol ICMP. There's ICMP type 8 and J no track. I'm gonna do it also for the output, but it's gonna be ICMP 0. ICMP type 0, J no track. Now if I do iptables-mvl -traw -mvl, I see here it's matching. Pre-routing is matching, post-routing is matching. So if I do contract-l, I see the ICMP session, but it's should be timing out in a minute here. It's timed out. I have no connection track for this. I can do the same thing for traffic that is pinging from the host. Right now I won't be able to ping from the host because I don't have it allowed. Operation not permitted. So I'm going to do this for the same thing. iptables-t insert in the output protocol ICMP -ICMP type 8 dash J accept. Okay. And I should be able to ping because I have related allowed 168.101.1. I'm able to ping right now because I basically did in the IP tables input tables I did to allow anything that's related or established. But however, I have a session. Right, so I'm still tracking it with a session. And if I want to not track it, then I need to add it to the output table, the raw output table. If I do IP tables, there's T net, there's T raw, dash insert output, dash P ICMP, dash ICMP type 8, and set it to J no track. Protocol ICMP type 8. That's fine. ICMP output ICMP type 0. So IP tables there's that's the wrong table. So I need to check the IP tables. There's the raw MVL. So I'm specifying here for the output. I need to add it to the output. IP tables there's T raw dash I output, and then dash P ICMP dash ICMP type. That's gonna be 8 dash J no track. So now I shouldn't have a connection tracking for my traffic going outbound 101.2.11. I cannot ping it for some reason. Ping. So because there is no connection tracking now, there's no session there's no session in the connection table. So IP tables dash MVL. So the related package, which is ICMP type 0, will not be allowed through, so I need to add it in the input direction. IP tables dash T dash insert in input direction dash P ICMP dash T ICMP type 0 dash J accept. Dash ICMP type. IP tables dash MVL. So I ping 192.168.101.1. I'll be able to, and if I see here, I don't have a connection anymore. So I don't have a connection tracking for this. So that's basically how to use the raw table. And we show an example on how to use it with ICMP to save your state table. So in this lecture, we will talk about one of the extensions, which is one of the modules extensions, which is connection limit. The connection limits allows you to restrict the number of parallel connection to a server per client IP address or block of IP addresses. How does this? If you specify -m connection limit, you are triggering the connection limit extension, IP tables extension, and you can specify a connection limit up to X number of connections, and then you can specify a connection limit above X number of connections, and then you can specify the mask by which you're gonna track the connections. Mask is the prefix. So you can track by, it makes sense to track by /32, which is going to be, the mask is going to be from 0 through 32. So if you do 32, that means you're tracking by host. And also, how are you going to track? You're going to track limit by source address. If you are trying to restrict the number of connection a given host can have to your server, you can specify a connection limit by source address, or you can specify connection limit by destination address. But for now, since we talking about IP tables as it relates to a host only, not acting as a router, the Linux box not acting as a router, then basically what happens here, let's say I have port 80 open and I want to restrict the number of client sessions to have to be not exceeding 10 or 100, just to limit my DOS, do a DOS protection. I can specify here -m connection limit. I can specify basically in a filter table. I can specify in a filter tables protocol is TCP, and then the destination port is 80. I'm gonna trigger the connection limit module, and I'm gonna basically track the connection limit mask 32 and connection limit source address based on source address, and then I can specify here connection limit above 100 is jump to reject. So basically that host exceeded the number of connection that they're allowed for your web server. So it'd be a good way of doing denial of service for your web server, for example. If you specify connection up to as your method of restricting, then you're gonna have to put it, basically you'll have to put as J accept and up to, let's say 100 connection. If this would be here, instead of connection limit above, if you specify connection limit up to, then you're gonna have to match it based on accept first, and then J does reject after that. So it makes a whole lot of sense if you're trying to protect your web server to make it basically reject if you're up to, or if you're above 100 connection. This way you don't have to do two rules to achieve the same goal. So let's see this in action. So what we want to do here is we want to test it out. And what we want to test it out is we're going to test it out for port 22 because it can easily be proven. So what I'm going to do is basically specify that up to 2 SSH session you're allowed. If you're above 2 SSH session, then deny. So we're going to go iptables -I insert in the input in basically table filter in the input chain, and then we're going to specify protocol TCP destination port 22 -m con limit, and we're going to specify con limit by source address, and then con limit above 2 above 2 con limit mask tracked by host. So we're gonna specify the mask 32, and then we're gonna specify con limit above 2, target reject. So now if I try to SSH to my servers, 192.168.101.200, that's gonna get allowed. New session 192.168.101.200, that's also gonna get allowed. If I try to have a third session, I'm not able to because I reached my connection limit. So that's a good way of restricting access to your host, especially if you have that host open to the internet and somebody's trying to brute force your SSH server or your SSH server. You can limit their connection to just 2, and basically they will be denied after the second connection. Clear connection timeout. So far we have been creating rules, but we don't have any logging established. So the way logging it gets established on Iptables is when you log traffic, the target log action, it's non-terminating, meaning that the next line would be processed. So if I have a target of log, the next rule would take action. So for example, in my rule here, I have the input and the output chain. And if I want to log accepted traffic, I need to put the same rule, put above it to JLog. And if I put JLog, that means it's gonna let it through and then log it and then process the next rule. So the logging has to basically be a separate target action in Iptables. In our case here, we're dropping traffic that doesn't match the input chain. We're dropping traffic at the end, and we want to log that traffic that's getting dropped. So let's do that. We're going to go to Iptables -mvl line numbers. I see here the line numbers 1, 2, 3, 4, and 5. Before 5, basically I'm allowing certain things and then dropping everything else. So before line number 5, I need to put a log entry matching basically the drop entry. So I'm just going to put Iptables -I input -j log -I input number. We're going to put it number 5, insert in number 5, there's j log, the target log, there's log prefix, Iptables dropped at input. Put a space at the end and then hit enter. So if I do Iptables -mvl now, I see here that I'm logging before I drop. This way I know what packets I'm dropping, because it's not matching any of my established connection, allowing port 22 and 80 incoming for new related established, allowing port 2280.443 for related established. 80 and 443 is basically for my return traffic for my host trying to get to the internet. And then this is port 53 for DNS. And then I'm accepting related and established ICMP traffic. And then I want to drop everything else after that, but I need to know what's getting dropped so that I can use it for troubleshooting purposes or for auditing purposes. And now I need to put, before drop, I need to put the same matching criteria, which in this case, everything. And I'm gonna log, and the default log level is 4, and prefix Iptables, I put a prefix Iptables dropped at input. I need to do the same for dropped at output. So Iptables -mvl, Iptables -mvl line numbers. And you can easily count it, the line numbers, but it just show you if you have like 100 rules, it's going to become cumbersome. So I'm going to insert it at number 5. -I output -j log dash log prefix iptables and dropped at output. Put a space at the end. This way it's easy to delineate it between different fields. So if I do iptables dash, I put it up top, so that's incorrect. Let me delete that. I didn't specify a line number, so I'm gonna go ahead and delete that. If I do iptables dash mvl now, dash line number, it's in the incorrect place. So it needs to be line number 1. Let me delete line number 1 dash d output 1. Now I'm gonna repeat the same thing that I did, but I'm gonna specify it's not line number 4. Let me retype it. Line number 6 dash g log dash log prefix iptables dropped at output, leave a space, iptables dash mvl. We see it's incorrect still. Iptables dash d output 6, it should be number 5. Because it's on the console, it's a little bit misformatted. So it's line number 5. So now if I try to get to the internet on any port, so it says curl http 1.1.1.1 port 5000, and that should be getting blocked. So now if by default, it's going to go to your default logging, which is in the case of Ubuntu for log syslog. We see here that it's dropped at output. If I try, so I'm getting that log. If I try to SSH to a port that's not open, 2525, see it dropped at input. So now I know what's getting dropped. So in the next lecture, we'll talk more about putting those logs in a specific place where we can basically delineate it from the syslog messages. So far we've been seeing the log messages in var log syslog, and we want to send this to a file. So we need to create a file under it, rsyslog.d, and then we're gonna create a file for rsyslog, and then we're gonna give it, if we go to that folder, you'll see that there's different configuration. We're gonna add a configuration file. So we're gonna do nano 10 iptables.conf, and we're gonna configure it to look for messages containing iptables. Then we are going to send it to var log iptables.log. Initiate a stop after that. Control X, yes, save, and then we are going to reload syslog. And if I try to connect right now, I should see that I'm gonna connect to an unopened port here, and that should have created var log to the var log ls. That you should have created iptables.log file. Get iptables.log. Now my Iptables entries are going into this file. I also need to rotate those logs. So what I'm gonna do is I'm gonna create a etc log rotate dot d ls. You see here examples. So we're gonna copy an example here, cp ufw, and I'm gonna call it Iptables vi nano Iptables. I'm going to specify Iptables.log. Rotate every, you can rotate every, 1 day, 10 days, whatever. So we're going to rotate every 15 days. 14. Compress. So we're going to leave the default here, and this would allow me to, let me exit out. No, I'm not going to save. Let me open it back up again. So I'm just going to keep it the same and just rename it to Iptables.log. So far we have used the regular chains that are in Iptables. In Iptables, there's the standard chains, the input, output, forward, pre-routing, and post-routing. But you're not limited to just those chains. You can create your own chains, and those are called custom chains. So the custom chains, basically what you can do is create your own custom chain by doing Iptables-n and then call it a chain, my chain. And this will create a new chain, and you can put rules in those chains. If you want to create a default, the default table is filter table. But if you want to create a chain and a table that is not the filter table, you can specify the table. So let's say if you want to create your own chain in the net table, you can specify a new myNet chain. And this is a way of simplifying how the rules look like. So in our case, we have the host. On the input chain, we have some, in the filter table, we have rules. And I want to basically make it a little bit more readable. The rules that we created so far are pretty simple, but let's say you want to allow certain hosts access to special services, and you don't want to mix it in the filter table rules. You can create a new chain and say, if the IP matches 192.168.0.70, I'm gonna basically jump to a new chain. You're gonna create a new chain called allowed IP, allowed something, allowed management, whatever name you wanna give it, and you're gonna basically jump to a new chain called allowed management, and in here you can specify, what you want to allow. You can specify to allow additional ports, for example. So this would basically make your Iptables more modular, that you can basically branch out into different chains based on source, based on destination, based on traffic port, based on other things. And we're going to see examples on how to branch out for specific things like, blocking malicious IP addresses and so on. So let's see this. So in my case here, I want to use rules, specific rules, to allow my host access to additional ports to 0.70, 101.200. I'm gonna SSH and create it through SSH. Iptables, I'm gonna create a new chain called allowed management. So now I created a new chain. If I do Iptables-mvl, I will see that chain here, allowed management. So in my case, what I want to do is basically branch out based on the source and then jump to that chain and allow specific ports. So I'm going to add into my input table, input dash specify the source 192.168.0.70, and I'm gonna jump to chain, the new chain that I created, allowed MGMT. So now basically this is up top, MVL, traffic comes in. I see already packets matching because I'm connected using that IP address. It's gonna jump to that chain, and the chain is empty. It's basically returning back. So basically it's gonna go to allowed management and then return back to the calling chain. I'm hitting that and I'm returning still back to, see here, 30, and this increased 30 and 279. I'm returning back to the calling chain. Because this chain is empty, it's basically nothing there. But if I want to specify, like for example, iptables dash I allowed MGMT, I'm gonna specify that, hey, I'm gonna move my rules to here, TCP protocol TCP dash dash multi-port dash destination port 22 dash multi-port dash dash D ports 2280 dash M contract dash dash CT state new related established this J accept. So I'm adding this to, I'm adding dash M multi-port. I'm adding this to my chain. If I do iptables dash MVL, I see my chain now, and you see the packets now are shifting to here. So it's matching up at the input chain, saying, okay, now this IP address matches. Now I'm gonna jump to that chain, and it's allowed destination port. It's destination port 22 because I'm connected over SSH, and this is an related or established connection. This is an established connection because I already have a session open. Then it's gonna match against this. So, and then it's gonna return me back to the calling chain if there's no match here. But the idea is to make it easier to make a difference between the different rules and branch out so that you can manage an individual module at a time instead of managing the entire firewall rule set. So if I do iptables dash save, I should save, I didn't save in a couple of lectures, etsy iptables rules.v4. Now if I do cat etsy iptables rules.v4, I see here the chain. You see here at the top there's multiple chains. This is in the filter table. We have the input, forward, output, and allowed, and then this is the NAT table, and we see here the NAT entries we created. And I see here that because I'm matching this IP address, I'm jumping through to that chain, and I have my rules allocated in that chain here. So this is an example on how to kind of make your iptables modularized. So now expanding on our previous lecture, so let's say I have a application running on this web server, running on this host, and I just want to allow this management IP that I define in my allowed management chain that branch it out to allow management chain to allow port access to a specific port that application uses for management. And don't want to allow anybody else. So if I do iptables .mvl, I have 192.168.0.70 that's allowed to branch out to this new chain, custom chain, and it's basically allowed port 22 and 80. But I'm just gonna allow port 8080 for that, just only that IP address. So the best place to put it is in the allowed management chain. So if I do iptables dash insert dash append to allowed mgmt, and I'm gonna append there's p. I don't have to specify the source now because it's basically matching IP address 192.168.0.70 and then sending it out to this chain. So now I can put specific ports allowed to that IP address without basically putting it in the general population of rules. So I'm going to specify protocol TCP dash D port 8080 and dash M contract dash CT state new related established, and then J accept. Okay, so now new machine target allow management allowed MT. So now this is allowed. However, the return traffic here on the output side is not allowed, so I still need to specify here. And this is basically for related established. The traffic goes into the box and then returns the responses. As long as I'm allowing related and established, that should be okay. It's not gonna allow a new session without being specified in the input chain. So if I go in here and create in the output, insert output, and I'm gonna insert to I don't have to specify the port. I can add protocol TCP dash port destination source port. That's the return traffic is 8080 dash M contract dash CT state related and established the G accept as port. So now the return traffic should be allowed. If I do iptables just MVL, I have now, if I'm matching IP address 192.168.0.70, I'm gonna go to the target allowed management, and in allowed management I'm allowing port 8080 for new related and established. So that should be allowed. The session will get established. The return traffic will match the output, and the output chain will say, okay, this is related and established. Then I'm gonna allow traffic to connect. I don't have to specify the destination here because this is stateful. I'm allowing just related and established. So now I need to run Apache on port 8080 so I can test it out. So via etc Apache ports.conf, and I'm gonna listen to port 8080. Alright, quit. And I'm gonna restart Apache. And now if I do netstat I see here it's listening to port 8080. So now if I try to go to port 8080, I see I'm established. Connection is established. If I do iptables-mvl, I see here my traffic branched out, and I don't have specifically allowed anything for other than 192.168.0.70 to access port 8080. So this is an exception from the general population traffic, which is allowed port 2280. So to prove it out, let me SSH to the default gateway. And and then try curl or HTTP 192.168.101.200.8080. I'll see it's stuck. It's not gonna respond. And now if I do var log iptables.log, I see here iptables dropped at input, and I see it's coming in from 192.168.101.1, and it's getting dropped to destination port 8080. It's getting dropped at input. So that allowed me to do just a specific access to one specific IP address outside the general population access to my host. So this is a way of you creating modularity and allowing exceptions in branching out to all management. Now, if I'm going to add another, if I have another application that requires management and it's running on a different port, all I have to do is basically allow it on the allowed management chain, and then allow the return traffic for related and established to return from the output chain, and this application is accessible, and I'm not changing anything for the rest of the population, or I'm not changing anything in my main chain. So my main input chain stays clean, or just the general population type traffic allowed. In this lecture, we will talk about hash limit, and this is an extension of the Iptables module that allows you to control traffic and do rate limiting, or that allows you to do denial of service protection and so on. So the hash limit basically allows you to control the number of packets per time window, or bytes per time window. And basically what it does is it allows you to put an upper limit on the number of packets received by time window, or the number of bytes received or sent by time window. And you can specify the hash limit to be up to a certain point. So you can say hash limit up to. So you can create your rules in a way that to specify up to, allow the traffic if it's up to X number of packets per second, per minute, hour, or day, and or above, allow up to or above. And up to allows you to kind of put an upper limit to the number of connections or sessions or bytes per second. Above allows you to kind of put a drop traffic above a certain threshold. And you can track hash limit mode. Mode allows you to track by source IP, source port, destination IP, destination port, or a combination of all these. So you can say hash limit, I'm going to track by source IP and source port, or destination IP, destination port. Hash limit source source mask, and then specify a prefix, allows you to track by network range or a prefix. If you put 32, it's going to be tracked by host. So I can put upper limit to the number of connections or packets per second coming from a certain host to be X number of packets per second. And if it exceeds that, then it's going to drop the exceeding packet. So hash limit allows you to specify track by source MAC, or also destination mask. source mask or destination mask, and also prefix here, same thing. You can basically track your traffic based on source or destination. And when you create a packet, you have to specify the hash limit name. And the hash limit name is used to track in the net filter tables. It's used to track the session based on the hash limit name under procnet IPT hash limit. It creates an entry file under that folder that has the name of your hash limit name. Basically, this allows you to kind of put a restriction based on number of packets per second, bytes per second, bytes per time window, whether it's second, minute, hour, or day. And you can track by source IP, source port, destination IP, destination port, and so on. Now, we know how to create custom chain. We're going to go ahead and create a new custom chain called log drop. Okay. This allows you to do two actions, which is log and drop at the same time. So in that chain, we're gonna append in log drop. We're gonna specify to j log prefix IP table drop IP tables drop log. We're gonna basically create kind of a chain to allow us to do a drop log and log it, and then IP tables dash insert. We're gonna put up top log drop. We're gonna put it up at the bottom actually. Append log drop dash j drop. So basically, this chain, what it does is it logs and drops the traffic. So logs and drops. So now I'm gonna use an example in the ICMP packet that's allowed. That basically I allowed ICMP that's related and established, and I need to allow new session as well, but I'm gonna restrict the sessions. Basically, new session is if I'm receiving, basically ping from my outside interfaces. So right now, if I look at ICMP, I don't have anything that is allowed, so I can not really ping the host. I cannot ping the host. So I'm gonna I use the hash limit to basically limit my packets per second to packets per minute to, let's say, packets per minute to 10 packets ICMP should be sufficient. So IP tables, I'm gonna insert, if I do IP tables dash MVL with 9 numbers, before I'm gonna create a new entry here, I'm gonna put it line number 5, IP tables dash MVL, IP tables dash insert, in line number 5 and input. I'm gonna say protocol ICMP type. I'm gonna leave any ICMP. I'm trying to demonstrate the hash limit. I'm gonna specify M hash limit, and I'm gonna specify hash limit above 10 per hour, 10 per minute. And so basically I'm gonna restrict the hash limit to above 10 per minute, and then I'm gonna hash limit based on hash limit mode source IP. So I'm restricting my source IP to only be anything that's pinging. It's gonna check the source IP and basically compile the information in a hash table, in a table listing how many packets was received during the time window, which in my case is a minute. So it's gonna count per minute, and it's gonna track by source IP. I'm gonna specify that hash limit source mask is prefix host, so it's gonna track by host. And I'm gonna call the hash limit name ping restrict, and we're gonna basically call m connection tracking. So I'm tracking, basically I'm gonna apply this to new connections, or just new connections. Related or established is allowed here at the line following it. So basically all I'm saying is new, I'm having a new ICMP packet reaching my host. If it's above 10 per minute, I'm gonna track based on source IP. So basically I'm gonna build my tracking based on source IP, and I'm tracking by host. You can track by network too. So if you wanna check all the IP addresses coming in from a specific net, pinging you from a specific network, /24, whatever it is, and if it's exceeding a certain number of packets, you can block the entire network. So here I'm just basically doing, as an example, the hash limit by source IP, the hash limit name, and I'm gonna track by connection tracking, connection track, dash CT state dash new, and if that's the case, then I'm gonna send it to the chain that is gonna log and drop the traffic. There's J log drop. CT state missing any. So if I do iptables-mvl, now I see here the ICMP. It's tracking based on ICMP. Above 10 per minute, burst 5. So by default, it's bursting half the number of I specified. And mode source IP, CT state new. And if I'm exceeding, if I'm above that threshold, it's gonna send me to the log drop chain, which is gonna log that packet and then drop it. So now let me see if I can ping. Request timeout, -f for log iptables.log. Let's see what's getting dropped. Drop that input. And the reason why it's dropped that input is basically have the allow management. Allow management is allowing me to only port 22 and 80. So I'm gonna remove that first line, iptables-d input 1, and I'm gonna let's take a look here. Drop that input. So now if I look here, I have the packet allowed and the CT state new for ICMP, log drop, and if it's above 10 per minute, it's gonna log it and drop it, but I'm not allowing it, so I need to add another line here to allow it. After, if it basically is within the threshold, if it's 10 per minute, if it's below 10 per minute, then it needs to allow it, and I didn't allow it here. I'm basically dropping it. So after that line, I need to add a line that allows it. So iptable-I, let me do line numbers. So I'm gonna insert, let me change this to also allow new, this line. So I can basically do it from the rules.v4 file. And then vi etc iptables rules.v4. And let me add to this input, I'm gonna add the new as well. This way, basically it's checking the packet against the threshold that I specified, and if it's exceeding 10 per minute, it's gonna drop. Let me restore. So apply the changes that I did in the file. It's easier to just change the file. So if I do iptables-mvl, now I see here if it's ICMP, if it's above 10, if our ICMP packet is incoming to my interface, it's above 10, then I'm gonna log drop. So now log drop is one of the chains that I created, custom chain that allows me to do two things. And then if it is within that threshold, then it's gonna basically not match this line, and it's gonna match the following line, which will be to allow it. So now I should be able to ping. So now I'm able to ping, but if I increased it to be more than 10 per minute, then I'm not gonna be able to ping. So let me run a ping here. I'll have multiple going. Ping. It's not even matching that, so something must be protocol ICMP. Hash limit above 1 per minute. Hash limit mode source IP. Connection tracking new. If it's above 1 per minute. CT state new. Oh, that's not considered new if I'm having a constant ping. Because I should be matching that. So let me drop because the session is basically reinforced. So it's not even matching a new session. So let me delete the sessions. Connection tracking -D. Deleted the session. There's 3 flows deleted. This is one of the flows. So let me ping. Let me see if that matched anything. So it did 2 sessions that matched. Oh, I'm looking at the wrong place here. So basically, I'm gonna have to change the state to be, because the state is, or the new state is just gonna happen only once. So the first when the first packet comes in, everything else is gonna be considered related and established. So in order for this to work, I'm gonna need to track related and established as well. So now it should work. Okay, now it's timing out. And if I do iptables-mvl, it times out. 1 minute passes, then it starts responding to one ping. iptables-mvl, because this is new, happens only one time in a session, and then the ICMP table, session table would stay in there. And now if I put it for new, related, and established, that means all the ICMP packets will basically be tracked. And if it exceeds a certain, 1 per minute, or basically 2 per minute, is gonna drop. So basically you're gonna have only 1 packet per minute that's allowed, nothing else. So this is kind of like a primitive example, but that basically shows you the an example on how to do this. In the next lecture we'll see additional examples. So in this lecture we will see how to configure the hash limit to control bandwidth. So the first thing you have to do is install speed test CLI, and I have it currently installed, but you install that, and basically speed test CLI, it gives you the bandwidth, how much bandwidth you're using, and let's firstly control like traffic download and upload speed. Let's see what the bandwidth is right now at the download side. So 52.96 megabits per second. I'm gonna attempt to I'm gonna basically configure to restrict the bandwidth. So in order for me to restrict the bandwidth at the download speed, I need to control the input side of the connection and configure hash limit to use bandwidth restriction. So if I do iptables-mvl, at the input side, I'm having traffic that is incoming for port 80443 related established. I'm going to need to put the rule for my hash limit above that rule. So I'm going to insert at number 1, iptables dash insert input dash protocol TCP dash multiport dash deep. This is going to be coming from source port, so traffic is in the input direction. If I'm downloading from my server, the traffic is going to be coming from source port 80 and 443. Source ports 80, 443. And then M hash limit. And then I'm going to choose the hash limit mode based on source IP. And then hash limit. In order for me to restrict, I can use above and drop what's above my threshold. So hash limit above, and I'm gonna specify above 512 kilobits per second, 512 kilobits per second, kilobytes per second. This is in bytes. And then hash limit source mask 32, and then hash limit name, specify name, download max, and then J, I'm gonna log drop. So this will do in effect like make sure that everything above 512 kilobytes per second will get dropped. Hash limit source mask, I mistyped that, case sensitive, dash hash limit name. And if I do speed test now, CLI, let's open a session to my server. So I see download speed here. So I'm sending it to log drop, so I should see things under fr log iptables.log. I should see things getting dropped and see quite a bit of activity here. If I do ls proc cat, see now it's 4.15 megabits per second. Because basically 512 times 8 is 4 megabits per second. So I was able to control the download speed. If I do cat proc net proc net apt hash limit, and so download max, and do this again, you see here that it's going to be tracking. So see, it's basically receiving traffic from this IP and it's kind of restricting it to 4 megabits per second. So 512 kilobits per second is 4 megabits per second. So basically what I'm doing here is restricting the download speeds to, and this basically is tracking by host. So that doesn't mean like my total bandwidth is going to be restricted to 4 megabits. Any single given session is going to cannot exceed 4 megabits. So this is pretty good if you're trying to restrict the traffic from a certain specific user IP to not exceed a certain amount of bandwidth. So my upload speed is still the same. I can control the upload speed in the output direction. Do I upload speed in the output direction? So let's input in output direction, and you see also what we were able to do is log drop right away. So output dash p TCP dash m multiport, just D ports will be 8443, and hash limit above We'll make it 512 kilobytes per second. And then hash limit. Now it's going to be destination mask 32. Hash limit name upload max. So I'm controlling my upload speed. And if I'm above that limit for connection track, I didn't use connection tracking here, but that's basically anything that matches the session, whether it's a connection, whether it's a new, related, or established. So total amount of bandwidth across all three of those. So hash limit upload max, and then J log drop. The TCP output, and I'm gonna use M hash limit. That basically enable that extension. Hash limit. Keep on missing the H, dash. So if I do the same speed test right now, and now my upload speed will be restricted to 4 megabits per second. So now I was able to restrict both my upload, download and upload speed. And this basically gives you a lot of flexibility when it comes to controlling bandwidth as well. Not only packets per second or packets per time window, only bytes per time window, which gives you pretty powerful flexibility when it comes to restricting your host access to prevent denial of service, restrict users to a specific amount of bandwidth, and so on. So in this lecture, we will talk about the module owner -m owner. This allows you to control traffic based on user. So let's say your Linux box has many users and possibly application running under a specific username, and you want to allow certain applications or certain users access or restrict access certain users to certain ports, for example. So in the previous lectures, we created allowed the policies for the host to go to port 22, port 80, and 443, and allow the return traffic in the input direction based on established and related for those ports. And related. And then here we allowed, on the output side, we allowed those based on destination port to 22, 80, 443 for new sessions, related, and established. Now that's all fine and dandy, but now I have a specific user that I want to restrict port 22. So this is where the module owner comes handy. So I can specify based on the module owner, I can specify the user ID owner, as username. For example, let's call this user 1. And I can also specify user ID owner based on user ID, not just user. And I can specify based on group ID owner, which group they belong to. In order for me to do that, I can use the output chain and specify in the output chain that if the M owner -- UID owner user 1 to block drop. But I want to be able to log that traffic too. and basically I'm gonna basically drop for new sessions. So if the state is new, city state new, which will prevent this user from establishing any SSH sessions. And I want to log that traffic. So basically on the output chain, I can specify first to log, if it's basically port TCP, destination port 22, and then M owner -- UID owner user 1 to J log, and then I can log prefix log UID, and then log prefix, a prefix that will help me look in the logs and identify if this user tries to open an SSH session. And then following that, I'm going to do the same thing, but the job will be to drop. However, because the log comes first, then basically it's going to log and then drop. So let's see how to do that. So we can add a user add user 1. So I do cat etc passwd. I see user 1 here is user ID 1004. So because the log comes first and then the drop comes after, I'm gonna add the drop first. Iptables -a. Well, since I added the user, let me switch user and see if I can do SSH. Sudo su user 1, and then SSH to 192.168.101.1, and I'm able to SSH. I'm getting this prompt back. I'm going to exit back to root, and then I'm going to do iptables -t -insert output. I'm going to do the drop first. So the p TCP -d port 22 -m contract -city state new, because I'm going to drop new connections only. That'll prevent the user from accessing SSH. And then m owner -UID owner. We'll specify user 1, and then -j drop, and then I'm going to put the log -i output -p TCP -d port, same thing, but now it's going to be log. New -m owner UID owner user 1 -j log, and then gonna log UID, log prefix iptables user 1 22 deny. Let's do TCP deny. That's why it's easy to search in the logs. And then now I'm gonna switch user to user 1, and I'm gonna try to SSH 192.168.101.1, and I'm unable to. Okay, to prove that it gets blocked, I'm gonna tail var log iptables, and I see here that user 1004 was denied, and then it's here in the iptable log, it's user 1 TCP 22 deny. So in the previous lecture, we set up the restriction based on user ID. We can set up the restriction based on group ID. However, this has to be the primary group ID of the user. So we can create we can put all the users that needs the same restriction in the same group and make that group the primary group for those users, and then apply the restrictions to those users if the traffic matches. Because when you initiate a traffic and you try to match based on group ID, it has to be the primary group ID. So I went ahead and deleted the groups, user del, user 1, user 2, user 3, they're all deleted. And I will create the group add restricted users. And I'm gonna create the users and put them in this group as their primary group. So I'm gonna create user add dash G, the primary group, which is restricted users, and put user 1, user 2, user 3. So if I do cat etc group, I should see this group ID, and then if I do etc password, I should see all those are the same member of the primary group as the group ID of restricted users. So now I can apply my restriction to all those users. I went ahead and deleted the 2 rules we created in the previous lecture, and now I'm going to change those rules to be based on the group ID instead of the user ID. So Iptable, we're going to create the drop first, dash, and then after that the log, same like we created, dash output. And this only applies to output, right? Cannot do input, will not have a user ID because that's traffic received by the server. So we're gonna specify port TCP, T port 22, dash M contract, and then dash CT state new, and dash M owner. And this time we're gonna specify the GID owner, and we're gonna put the name of the group restricted users, and then we're gonna specify to J drop, and then we're gonna add the log entry which will go up above it, output dash P TCP dash dash D port 22 dash M contract dash dash CT state new dash M owner dash GID owner restricted users, and then J log, and then log UID to log the user, and then log prefix Iptables restricted deny 22 TCP. Okay, so now let me switch user to user 1 and then try to SSH to my server, and I'm unable to. I'm gonna exit and switch to user 1. I mean, I switched the other time to user 2, super user at 192.168.101.1. I'm denied. And then exit user 3, try the same thing. I can't. So we'll look at the logs now, and we'll see tail f bar log Iptables. I see here, we see group ID, and we see here Iptable restricted deny, group ID 1004, user 1001, 1000, group ID 1004, user ID 1003. So this allows us to have more of a group-based restriction-based group restriction for traffic based on group membership, but it has to be the primary group of the user. In this lecture, we'll talk about using IPset to simplify the management of IP addresses and ports. And the IPset feature or IPset package allows you to do IP address grouping of IP and ports so that you can reference them in your Iptables policy as a group. So you can reference a list of IP address with name. For example, you can have an allowed IP list, IP set that has the list of IPs you have allowed to access your server. You can have a list of ports like similar to service group in Cisco and Palo Alto that has a list of ports and protocols allowed, TCP, 443, and so on. And the IPset feature can be installed using apt install IPset. And you can create different types of sets. The notable ones we're gonna talk about are hashnet, which allows you to create a list of IP addresses by either IP host or IP/mask, and this allows you to create a group of IP addresses. And you can also use bitmap port. So this would allow you to create a list of ports that is allowed in your policy. And the way you create an IP set is IPset create, and then the name of the IP set, and then type. In our case, it was going to be hashnet or bitmap port. And the first one would be to allow a list of IP addresses. Second one would be to allow a list of ports. So let's look at this in the lab. In our case, we decided to allow only port 22 and 8080 to be accessed by a specific IP list. So first we have to install IPset. And then we can create, let me SSH into it. So we can create IPset create allowed MGMT, and then type is hashnet. So that created, if you do IPset list, that shows you the IPset is type hashnet. And then we can create an IPset create allowed management ports. And then we could call this bitmap. We use type bitmap port. We're gonna call the range, you have to specify the parameter range 0 through 65535. And then we're gonna add our IP addresses to the list. IPset add allowed MGMT 192.168.0.0/24, and we're gonna add allowed MGMT 192.168.1.1.1 as an example. If I do IPset list, I should see those. And then on the ports, we're gonna add a port to be allowed. So IPset add allowed MGMT ports. We can add TCP 80, and we're gonna add TCP 22. We're gonna add TCP 8080. So if I do IPset list, I have the ports here. Members are 22, 80, 80, 80. You can add also a UDP port. UDP, can use an example, UDP 53. And if I if I do Iptables -mvl, I want to be able to use this in my policy. I'm gonna basically allow my network management IP set list. I'm gonna allow those two IP ranges or IP addresses to be able to connect to my server on port 22, 5380, and 8080. Iptables -mvl insert an input. We're gonna choose we're gonna choose M multi-port, and we're gonna choose M set -- match set allowed management allowed MGMT that basically allows it to use the trigger the match set, and this will be source based on source, and then M set dash match set allowed. We're gonna choose the allowed IP port, allowed management port. And then this will be this destination port -J accept. There's no need to do the multi-ports, so iptables -mvl. So right now, basically I'm matching, and you see here it's already matching, but I want to delete this line and just use the contract. Iptables, we're gonna add -m connection tracking -ct state new related established. This way I'm triggering the connection tracking. And right now if I go in here and create a new session, 192.168.101.1 101.200 Ubuntu. I do iptables -mvl. I'm seeing here in the input side it's matching on this source IP and destination port. So let me try 8080 HTTP or port 80 101.200. We see here it should be also iptables -mvl input. You see here matching additional traffic. To prove that this one is the one that's getting used, iptables -I input line number 2 -set -m set -match set allowed management port. So I'm going to restrict the traffic. Any other traffic coming in from other IP addresses to be denied. -G drop lock drop, and here we're gonna shoot dist. So iptables -mvl. Now I want to see if I can trigger a drop. So do IP set list, and I'm gonna delete one of the IP addresses here, 192.168.101 IP set. To delete an IP address from the IP set, delete, and allow MGMT. I'm gonna delete the IP address 192.168.101.1, and if I go to 192, 192.168.101.1, I should be getting dropped because I'm not in the allowed list. So let me go there and SSH to 192.168.101.200, and I should be getting dropped here if I do tail var log iptables.log. I see here I'm getting dropped 192.168.101, and for destination port 22 it's getting basically dropped. So by doing this, I basically restricted the management or the IP ports 22 and 80, and I can restrict it to port 22 only. So I do, let's say I have a web server, I have a server as a Linux host that I want to basically restrict port 22. I can basically use this method to restrict my port. So I'm going to go ahead and do ipset delete allowed mgmt ports, and port 53, 80, 80. So if I do ipset list, I see only port 22. So only port 22 is blocked and the others are not. If I do curl 192.168.101.200, I see here, if I add, I see here that I'm able to, because that's not, I'm able to curl to that IP because that's not restricted. But if I add it back to add port 80, I'm gonna be basically unable to connect to it, and I would see this getting dropped in my iptables log here, destination port 80. So you can basically create a set for your allowed IPs and allowed ports, and use this in your policy to simplify the addition and deletion of IP addresses. You don't need to create a specific line for each IP address, and we'll see how to use this also for creating other things that will be helpful in maintaining your policy. So in this lecture, we will use ipset to block blacklisted IP addresses that have been seen in the wild that are hacking or doing malicious activities. So we're gonna, since basically iptables, nice thing about iptables is it's Linux, and there's so many people who created good tools and to allow you to shell script things. And one of those tools is the this tool here, ipset blacklist, used written by Trick77, and this is in GitHub, so you can go to that link, GitHub Trick77. You can also download this into your machine to be able to use it. So we're gonna go ahead and do that here. We're gonna do apt install git, and so that we can do git clone and clone this project and use it in our iptables experiment. So we're gonna git clone, and we're gonna git clone this project. And if we do cd ipset blacklist, this is the project here. So we're gonna go to that folder ipset blacklist, and if we do ls, there's a bash script that basically runs, and there is a configuration folder, configuration file. This configuration file holds the configuration of the that gets used by the script file, and it's basically creating the ipset list that gets used as blacklist, and change it if it collides with a pre-existing IP. This is the temporary one that gets created to kind of download the latest IP addresses and swap it with the existing blacklist, so to not cause any disruption. And then you need to have a folder created here. So I'm going to open up another SSH window, and make dir etc IP set blacklist. So I created the folder it's going to be using to put the files in. And then verbose verbosity level, if you want to make it verbose. So we can choose yes at the beginning as we're testing. And this will create the IP set table binding if it does not already exist. So basically it's going to add an IP table line to block this those IP addresses in the list. And then under blacklist, the blacklist array, it's basically a list of URLs that it uses to download. And then the maximum element size we can is 131,000. I'm going to double that to 264,000. And there's also, okay, so the basic configuration file, vi update blacklist.sh. There's also another variable for maximum hash size. So hash size, we're gonna increase from 16,384 here to something else. Hash size. The hash size is going to be multiple of 1024. So I'm gonna basically 1024 times 16,384. Okay, and 24 times 32, 32,768, 32,768. So basically this is the variable that gets used to create the IP set list. And then I am going to do update, run the bash script file and point it to the configuration file. And basically we see it here downloading the IP address lists. And basically number of blacklisted IP network found is 72,484. If I do IP set list, see it downloaded all the IP addresses. One thing that is pretty nice to have is the emerging threat rules. So I want to add the emerging threat rules, which is basically maintained by reputable vendors like Cisco and others. And it's used by IPS vendors, IPS solutions like Snort and Suricata. So I'm going to use that. So I'm going to add this to my configuration file. Let me add this as a line here. Between quotation, I'm going to put remark to follow what we have here, emerging threats. I'm going to run it again. And we see it here downloading. And I still have 72,490 found. Let me vi update blacklist.conf. vi IP set list blacklist.conf. And I'm gonna choose verbose is yes, force equal yes. So that basically creates an IP table line for me when I specify force equal yes. So I'm gonna choose force equal no, and I'm gonna do IP set. I'm gonna do IP set list more. So here we have the hashnet. So I'm gonna destroy that IP set destroy that blacklist and run it again. It's in use by kernel. So because it's used by IP tables, we cannot use it. So iptables-mvl. I see this basically that script added for me a line for input to drop anything matching the blacklist. So I'm gonna delete the top line iptables-d input 1. So I want to basically remove it from adding lines into my policy because I'm going to create it manually. So I deleted that and I'm going to destroy the blacklist, and then I'm going to run it again, run that script. So right now it's basically asking to please create the blacklist, and use that basically to create the blacklist. So I'm going to create the blacklist because that's something I'm going to be using. 32768, this is the hash size, and the max number of element 264,000. So I created that. Let me run the command again. So now it's complaining about Iptables does not have the needed input added using this. So I also use customization here, so I'm gonna remove that section in the Iptables that creates the Iptable line. This way I have flexibility to what I want to do. So create the Iptable binding if needed. I'm gonna remove that section. So that basically is removed. So let me go ahead and do that. So now I see it just downloading and using the IP set list that and you see still 72,490. So I'm not sure if it's downloading emerging threats or no. So I just want to make sure that it's working as I expected. And if I see here, so I see here it's using the I. So I want to just change my configuration file. I'm just gonna have the list that is the one that I want, which is the emerging threats, and see how many it pulls out. I'm gonna ram out the others. So I'm just gonna use the emerging threats. Run the script again. 2392. So that's 2392 IP addresses in there. Good chunk of IP addresses. If you're gonna use just emerging threats or can use the others in the list, I'm just gonna use the emerging threats one. So if I do IP set list, I see this in my list, and you see here it's not only just IP addresses, it's IP addresses and ranges and network masks. And that basically is for IP addresses that are considered risk based on data gathered by different vendors. And this is very reputable. Now I need to be able to use this in my list. So I'm going to use Iptables dash I input. I'm going to, since I cannot really test it on input because those IP addresses are not going to connect to me, I'm going to add it to output. And just show you, so basically it's going to be the same way. I'm use mset, and then basically since this is the outbound traffic, I'm going to match based on destination, match set, and then blacklist, and then there's J log drop. And then we have to specify that this is for destination. Match set I output dash m set dash dash match set blacklist, and then test. Okay, so now if I take one of those IP addresses here and then ping it, I see here it's getting dropped. If I do cat etsy tail -f_var log IP tables, I see it getting dropped, the IP address that I'm trying to reach. So basically right now, because I have this in my output, I'm blocking any IP address, any traffic to those malicious IP address lists. And you can do the same thing for input. You just need to add it into your input chain. Okay, in this lecture, we want to save the work we've done. And basically, IPset requires that you save the IPset configuration. So if we do IPset save, and then pipe to etc ipset.conf, this would save the configuration in ipset.conf via etc ipset.conf. And basically would save the set list that we created, and this way it gets used when it reboots. But we have to basically point Iptables, create an Iptables plugin to add this as a boot up script to load the IP set before the Iptable loads. So if we go to cd user share netfilter persistent plugins.d ls. So this basically is the place where it loads the Iptables when it reboots. Line 15 or step 15 loads IPv4 tables. Step 25 loads IPv6 table. We're gonna need to create another file, vi10 ipset. This basically loads, because it's 10, it loads before 15 and 25. So in this file, we're gonna create this file. You can use nano or you can use any other VI. I'm using VI right now. Bin bash, and we'll basically put sbin ipset restore, so that way it restores, and dash exclamation sc dash backslash ipset.conf. This way it saves it. It basically loads it at boot, and then we're gonna change mode +X to make it executable. And then we're gonna also do iptables -save etc iptables rules.v4, and then reboot to make sure that everything comes up correctly. We're gonna basically when it reboots it because of the console, it just falters in the middle, so we're gonna stop it and start it. Okay, so as it reboots here, we're gonna see if we have any errors. We see here it's loading up, and we just look and see here if we have everything loaded. Let's check Ubuntu. If I do sudo su, I have to be in root. ipset list. We see the ipset list. It's survive reboot. iptables-mvl. We see here the output set list is there. If I do ipset list and then ping an IP address here, ping 80.229.204.1, I see it's getting blocked. Tail-f var log Iptables. We see here the packet getting dropped for that malicious destination IP. So this way you can create a script that loads the IPset configuration upon reboot, and that's going to be used in our next lecture to use FQDN objects to control our traffic in Iptables based on names, not IP addresses, because maintaining it based on names sometimes is more difficult, especially if you have a dynamic IP address that you're using to try to get to your server. It could be a cloud-based server, and your IP address changes, and you want to be able to always be able to get to that IP address even if your IP address changes. That's why we're going to use FQDN objects to achieve the goal, and we're going to use the components we created in the previous lecture, which is the IP set and Iptables. So in this lecture, we will configure FQDN objects which is basically a feature that's done by pretty much all the firewall vendors, Palo Alto, Cisco, Fortinet, and so on. The FQDN objects are pretty critical to make your policy dynamically updated for latest IP addresses of your hosts that are connecting to your special Linux host. Maybe you have specific ports that is only allowed for specific IP addresses. So basically we're going to use the FQDN names, and the FQDN names are resolved by DNS mask. DNS mask is a lightweight DHCP server and DNS forwarder for Linux hosts. And the DNS mask, one of its features is to be able to update IP sets. You can point the DNS mask configuration to a FQDN name. For example, www.google.com, and update an IP set name. You can have multiple IP set names updated for any time the host resolves or there's a resolution for a specific host like www.google.com. You can have this for your environment. Let's say your admin hosts are has specific names, and then if your host changes IP addresses, your internal DNS gets updated, and then basically because your internal DNS gets updated, the actual entries in the IP set tables gets updated as well, and you have your admin hosts allowed all the time, even if their IP address changes. We can do it for outgoing traffic as well, to update an IP set name for specific DNS names and use it in our policy. Other things that needs to be done to make sure this FQDN object gets updated all the time. This can be achieved by running a cron job to run NSLOOKUP for your DNS names that you have in your policy, in your DNS mask policy that points to objects in your IP tables, that resolves FQDN names and updates the IP set tables automatically, and updates the IP set for those IP addresses that needs to be allowed, either incoming or outgoing. In order for this to happen, we have to get the DNS mask configured. We're going to have to create an IP set for the objects we are going to be using in our DNS mask configuration, and we're going to be using in our policies. And then we have a cron job that gets created to update the entries, even if nobody's trying to reach the server. Basically updated automatically every so minutes. The standard out there, the lowest standard out there for DNS FQDN updates is 1 hour. But to make sure that our policy, basically we can demonstrate it faster, we're going to set it to 2 minutes, which is 120 seconds. And we'll set the IP set entries to expire in 5 minutes. You can set, when you create an IP set entry, you can specify how much time to use to expire. So our IP set entries, the IP set that we're going to create, we're going to set it to expire the entries in 600 seconds. We're going to basically run our cron job every 2 minutes to run the NSLOOKUP and update the entries in IP set automatically. So going back to our Linux host, the first thing we have to install is apt install DNS mask. Choose yes on that, and this will install the DNS mask software, and then the configuration is under vi etc dnsmask.com. There's multiple things in our policy that we are going to be setting in our DNS mask configuration that we're going to be setting. We want to time out the DNS mask entries, because this is kind of a local caching server. So we want to also time out the entries in 120 seconds. So we're going to set the local cache to time out in 120 seconds. I'm going to just basically append the configuration to the bottom of the list here. And I'm using vi You can use any other tool that you want, that you like. Well, maybe VI is not such a good thing. Let me SSH actually to the box. This way I can use VI. Console doesn't work very well. At the bottom of the list, I'm just going to add a line here. Max cache TTL equal 120 seconds. That basically will time out the entries in 120 seconds. And I'm gonna set my DNS servers to use for forwarding DNS requests. I'm gonna use the OpenDNS because it protects me from malicious IP addresses. And I'm gonna create an IP set here, and I'm gonna use Iptables and an entry in my domain, test.iptablesexpert.com. When something resolved with this DNS name, it's gonna go on the IP set allowed special access. We call it special access, and allowed incoming. So I'm putting this IP address into two IP sets. So I'm gonna create the IP sets. It's not gonna work until I create the IP sets. But so right now I'm basically, anytime the DNS mask resolver resolves this FQDN objects, it's gonna basically take the IP address and put it into those two IP sets that I have created. There's two IP sets that I have named after the FQDN object. So that's how you can add FQDN objects to your IP set. And I'm gonna listen address equal 127.0.0.1, listen on my loopback, and then no DHCP interface because I'm not using the DNS mask for DHCP services, because it can be used for also DHCP services. I'm going to choose bind interfaces so that it binds to its interfaces, and it's all the information that I need. I want to be able to resolve directly from my Linux host using that. So I'm going to use using the DNS mask. So I'm going to point my network configuration to use, instead of the Google DNS server, I'm going to use my local server. So I'm going to go ahead and service restart DNS mask. Service DNS mask restart. And service networking restart. And if I do nslookup, I should be resolving from my internal host. So there could be an issue here, iptables-mvl. I don't have the input, should have port UDP53 allowed if it's local. So I need to add that as an allowed service. So because right now I input, this basically shows up on my input interface. So I'm gonna specify source is 127.0.0.0.1 to destination 127.0.0.1. Allow allow the port 53. So iptables-i input -s 127.0.0.1 -d 127.0.0.1 .1 and -p udp -d port 53, and I'm gonna allow this j accept, and on my output as well, because basically my host is restricted. -d 127.0.0.1 -p udp -d port 53 -j. This basically output would be let me try this right now, see. So I'm still not getting through. Let's do tail-f var log iptables.log to see what's getting dropped. So we see our source in 127.0.0.1 and destination 127.0.0.1. So this is dropped at output, so I need to allow this at the output. So same like I did with the input, I'm gonna allow with the output. Let's try now. Let's see if something is getting dropped. So at output, dropped at output in equal out equal loopback 0 UDP source port 53. This needs to be source port, not destination port. Okay, so now it's getting resolved. So let me clean up my iptables here. iptable-save. Let's see iptables rules.v4. And now I need to create my ipset. So ipset create type hash net. And then timeout. I'm gonna choose timeout like we specified. We're gonna timeout in 600 seconds. Then ipset create allowed incoming hash net timeout in 600. And if I do nslookup for test.iptablesexpert.com, see now it's resolving. So if I do ipset list allowed incoming, I see here the host is added automatically to my allowed incoming ipset. And if I do ipset list special access, I see here that it's allowed already, and I'm timing out in less than 5 minutes. So it refreshes less than 5 minutes. So I'm gonna time out those entries, and I need to save my configuration. So I can basically do ipset save and pipe to grep the allowed incoming, because I want to add it to my ipset without anything else. So I'm gonna choose this line here, copy it, I'm gonna add it to ipset.conf. I'm gonna add it at the top. Save. And I'm gonna grep for special access. I'm gonna copy that. And this way, basically, it survives the reboot. Add it here. And now, based on this, I'm gonna use it in my policy. So let's pretend that there's the web server, Apache is running, or you're managing that, Raspberry Pi, or manage that IoT Linux box, or you manage it, you manage it from a specific port, let's say 8095. So, and you want only to have the IP addresses in your FQDN matching those IP addresses to be allowed access to your server and nobody else. So what I'm going to be doing is running my HTTP server on that specific special port via etc Apache ports.conf, and I'm going to run on listen on port 8095. I'm going to listen on another port here so we can look at it from perspective of running at multiple ports, and we're going to use our ipset skills that we acquired from previous couple of lectures. I'm going to restart the Apache server. So now if I do netstat grab Apache. I see here I'm listening on port 8095 and 8096, but I won't be able to access those because it's not in my policy yet. So now I need to add it to my policy, and I'm gonna basically allow the traffic on the outbound side if it's related and established, on the inbound side for new, related and established, and then on the inbound side is going to be destination port 8095 and 8096. On the output port is going to be source port 8095, 8096. And I need to create a list of ports that we have already a list of ports that we allowed we used in our previous example. And if we do IPset list grep name, we see here allowed management ports. So we're gonna append to that allowed management port IPset list, and then we're gonna add in our allowed management port IPset add TCP 8095, 8096. So now it's added in my ports. This is gonna be my destination port. So now all I can do is add that list. So I need to save it too, because I need to save it in my ipset.conf to survive a reboot. So I'm gonna add it here. Add allowed MGMT ports 8095. Add allowed MGMT ports 8096. And then iptables-mvl. We see here it's allowed management, it's match set allowed management, and allowed management ports. It's there, so technically those ports allowed in management ports will be allowed by this example here that we had previous couple of lectures. But we're gonna supersede it by the one up top. So those are also trusted IP, but I'm just showing you how to use the FQDN objects. So IPset now dash m set dash match set allowed what was the two special access, and then source, and then dash m set source dash m set dash match set allowed management ports dash m state contract dash ct state new, related and established. And I'm going to allow this to be j accept. Okay, match set allow management ports. We need to specify destination here. So we're saying, okay, match the special access list as a source and match the allowed management port as destination port, and make sure this connection is allowed for new, related and established. And I'm putting it up on top because I don't have anything after input specifying any line number. And I'm gonna specify j accept. Iptables. And then on the output direction, output dash m set dash match set allowed MGMT ports with source, and m connection tracking dash ct state related and established only. This is my return traffic. Dash I. Oh, capital I. So now I should be able to connect to the server on those two ports, 101.280.95. I see I'm able to. 8096, I'm able to. And 5 minutes should have elapsed, and IP set list special access. See, it's timing out in 31 seconds, so because I'm not refreshing it with a cron job, it's gonna time out pretty soon here and I won't be able to access it. So let it time out. Because I set it to time out. I set my list to time out in 5 minutes, so something has to refresh it in 5 minutes. And I set my DNS mask -f etsy dnsmask.conf. I set my DNS to time out in 2 minutes. So the DNS mask should have timed out already. So now it timed out. So if I try to connect, I won't be able to. If I open another window here, 8095, 8096, group 8095. I see here 8095 is timing out, is getting dropped. IP table drop log. Not sure why 8095 is allowed. I might be running into an issue with the other. This is allowed destination. I'm basically hitting this policy now. The policy after, because I have the same ports in both policies, so I'm kind of, so IP set list. Let me remove 192.168.0.0.24 IP set delete from this allowed management, even though that's going to kick me out of the session, but just to show you. So I lost my SSH session, but I still have my console. So IP tables. So now if I do NSLOOKUP, so IP set list, special access, nothing. If I do NSLOOKUP test.ip tables expert.com. Now if I do special access, now I see it. Now I should be able to SSH again. So the moral of the story here is you can allow your, based on FQDN, right? So in order for us to kind of make this refresh automatically, so this way, anytime your IP address change that you're trying to access your Raspberry Pi that's sitting out there, or your IoT device, or your cloud server, anytime you connect to it, even though your IP address changes, if you have a way of doing dynamic DNS update, which everybody knows how to do that, to get a dynamic DNS and update your IP address anytime it changes, your server will automatically have that IP address information. To do that, you're gonna have to create a cron job, so to run through and run NSLOOKUP against the IP addresses that you're using in your policy. So we're gonna basically create a simple NSLOOKUP update. Well, it's called a simple bash script. We're gonna call this nsupdate.sh, and I'm gonna put a top in bash. and nslookup test.iptablesexpert.com. So now we're going to change mode to make this file executable, and we're gonna, so right now when I did ipset list, I realized that I was saying 5 minutes, but it was really 10 minutes, 600 seconds. And if I do ipset list special access, I see the file here, I see the IP address, and it times out in 600 seconds. So I'm gonna need to change that to 2 minutes so I can demonstrate it faster. So in order for me to do that, let me do iptable-save. Let's see iptables rules.v4. Let's see iptables rules.v4. And I'm gonna remove this line. So I can remove that list. iptables restore. So now I'm gonna ipset destroy special access, and ipset create special access, create special access hash net, and then timeout will make it 120 seconds. And if I do ipset list special access, I see here it's 2 minutes, so I need to create a cron tab job to use that NS update. Refresh this entry every 2 minutes. You don't need to do it every 2 minutes. Really, it makes sense to do it like every hour, 30 minutes, or something like that to make it not run too many times, but technically 30 minutes should be sufficient. So I'm going to create a cron tab entry, and I'm going to add here asterisk divisible by 2, asterisk, 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 root, ns update .sh. So this will basically run it every 2 minutes. So ipset list, ipset list special access. If I do date, and see technically at the beginning of the next minute it's going to be divisible by 2, so it should run and update the special access ipset. And now I can use it in my iptables. So let me go back to the rules file and remove the hash by this entry. iptables restore. And if I do special access, yeah, it's about to refresh right now. So now I see the entry refreshed automatically. iptables-mvl. You see here it should be 0, but if I go to Apache and refresh, I should be hitting that line. So technically with this feature, you can have any device that you're managing out in the field, for example, be just configured with this type of configuration. And anytime your IP address that you're managing from changes, it basically would allow the new IP address. So that's a very powerful feature you can use in Iptables combined with IPsec and DNS mask. In this lecture, we'll see how to use geo-IP blocking. The first thing we have to do is install a package, apt install Iptables add-ons common, and basically this also installed Iptables add-ons DKMS, and basically that adds additional software to allow for this feature. So just make sure also apt install Iptables add-ons DKMS. And then the next thing we have to do is install libtext CSV XS Perl, the Perl extension to read CSV files. And then we need to create a folder for under user share xtgeoip. We need to create that folder. And then once that's done, we are going to run user lib Iptables add-ons xtgeoip _dl. This downloads the geoip database in CSV format for both IPv6 and IPv4. And we're gonna create a script to go through the steps necessary to migrate the CSV files. If you open up the CSV file for do ls, I should have geoipv6 CSV cat geoipv6. So this is basically the IPv6 addresses that's been allocated so far, and then geoipv4 geoip country who is .csv. This is the IPv4. The two CSV files, we basically need to run a script that takes those files and translate them into geoip files, build them into the CSV, the extension Iptables extension to use in your Iptables policy. So we're gonna create a bash script xt geoip update .sh. We're gonna run bin bash, and we are gonna temp dir a temp directory. We're gonna use the make temp -d to use to download the CSV files, and this is where it's going to be much cleaner. CSV files equals, we're gonna use the temp dir that we created. Once you run the xtgeoip download, it's gonna download two files, those two files that I showed you. It's gonna download them in the temp dir. So we're gonna create a CSV files variable to hold those two CSV files as parameter for our build, for our GeoIP build software. So we're gonna basically specify country who is .csv and temp dir geoipv6.csv. So those are the two CSV files that gets downloaded when you run the update. We're gonna cd to temp dir, and then we're gonna run the Iptables add-on xtgeoip _dl, and we're gonna switch user lib Iptables, run also the xtgeobuild Iptables add-ons xtgeoip build -d, the directory is going to build in. And then basically we pass it the variable for the CSV file parameter. And then we're gonna finally, once we're done, we're gonna remove the, so we're gonna basically hold a variable also for the current folder by running the command pwd and piping this to a variable pwd current folder or current folder. pwd, run pwd. So we're gonna cd to temp dir, and then after we run the build, we're gonna cd to current folder, cd to current folder, and then rm-r temp dir. This is the output of temp dir, or the output of the variable temp dir, and then we're gonna exit 0 if everything shows fine. So we're gonna change mode to executable, xtguip update, and then run it, test it out. It basically is downloading the folder. It's gonna download, creating the temp folder, downloading the CSV file, and then running the files to create. And here we have line 8 failed. So let's open up line 8. I have the wrong command, all caps. So let's run it again. So basically it's creating the files and running them through the utility to build, and basically it should be putting them under ls user share xtguip. So it is creating those files that has basically the locations. If I do ba cat bf.f4, so basically those are build files that are not readable, but right now we basically can use them in our policy. And I'm gonna install utility apt geo IP database, apt install GRP database. GRP database, so I can query the geolocation IP and GeoIP bin. And GeoIP update. This is basically for me to be able to update. You basically check and see which IP addresses are belong to which region. Database. So if I do GIP lookup 1.1.1.1.1, it's Australia. So now to make sure that this is getting, basically this list is getting updated, we're also gonna do cron tab to run this job, ls-alh. We're gonna basically run a cron job to run it nightly. So cron tab -e, we're gonna run it at 5923 root cron tab -L. So now this is gonna update nightly. So this way your GeoIP database is always up to date. So now we had combined a lot of dynamic blocking. If I look at input -NVL input, we see here that we should have a blacklist block. Well, we have the blacklist allowed dropped in our output chain. So I have here match set. So we have the blacklist, but it's not blocked currently. I have it here, blacklist destination log drop. So I need to basically make this dynamic and basically add my blocking features, geolocation and blacklist. I'm gonna add them to a chain. This way I check that chain for input or output, and basically if there's no match, it's gonna return back to the calling chain. So I'm gonna create a new chain here, Iptables -N denied. I'm gonna basically, since this is gonna be just to deny IP addresses that basically are my blacklist and the geolocation. So I'm gonna add this as a new chain, and I'm gonna basically make exclusions for my internal traffic, RFC 1918, and my loopback 127.0.0/8, the loopback networks, or the internal loopback networks. So I'm gonna insert into my denied, or append because it's empty, denied check dash source 127 the private RFC 1918 192.168.0.0/16 10.0.0.0/8 and 172.16.0.0/12. I'm gonna basically, if it's any of those sources, I'm gonna return to the calling chain. This way, those are excluded from my check for additional things. Now I'm gonna basically add denied check, and then I'm gonna put the set -- match set name blacklist, and then this is checking for source, and then I'm gonna log -log log prefix. So I'm gonna basically block if it's source. So because I'm using this as a global check, right? So I'm gonna check for if the blacklist is in source or in destination. So glog prefix Iptables block incoming blacklist, and I'm gonna check for destination. I'm gonna basically now drop basically I'm putting the log first and then the drop. This way I know where it's getting dropped. So if it's not part of my source, then I'm gonna do a destination check and log. If it's in the blacklist, destination check, and I'm gonna call this outgoing blacklist, and then I'm gonna do the same thing but choose drop. This way I know if it's in blacklist. Now it's hit this and it's gonna drop. So now I'm checking for the blacklist. It's probably better to have the geolocation checked before the blacklist, but you know, we can put it in that order, that's fine. So iptables dash a. Let's say in my case, I want to allow, I want to block certain countries. So deny check mgyp. Let's say I'm gonna deny France, for example. So I'm gonna specify mgyp dash dash source country code fr, and then dash j. If it's matching source code France, then I'm gonna j log, and then log prefix destination iptables, basically the prefix of my log, iptables geo block incoming, and then I have 2 mgyp. So now that it's logged, it's gonna drop. And you can have multiple countries in the same list. You can specify, for example, here I can specify China. Nothing against China, but Kenya, for example. And I'm also gonna put log prefix block incoming. And then now I'm gonna specify drop. So let's see here, iptables dash s denied. This is to show you what you have. So basically, if it's 192.168 source, I need to add 192.168 destination as well. This way I'm whitelisting the entire, or returning to the calling chain. So let me add up top dash s dash I at the top, deny check dash destination 192.168.0.0/16 10.0.0/8 172.16.0.0/12 dash j return. If I do s deny check, now I see here if it's destined to RFC 1918 or sourced from RFC 1918, I'm gonna return to the calling chain. If it's sourcing from blacklist IP, I'm gonna log and then drop. If it's destined to a blacklist IP, I'm gonna log and then drop. And if I have my GeoIP, this is basically GeoIP incoming source country. Source country, so I have a couple of source country. I can also do destination country, so I'll add this at the end. So for source country, now I'm gonna make it destination country. I can add basically all three: France, China, and Kenya, and then I'm gonna specify that's basically I changed it from source country to destination country, and I'm gonna say IP block outgoing, and then log and then drop, log and then drop. So in effect, this chain that I created, now I can be calling it from input and output. This way I am hitting two birds with one stone. I'm checking for blacklist, I'm checking for country block, and I have it in the same chain. So now I can add it to my iptables dash insert input dash j. So basically off the bat, I'm gonna go to jump to chain deny check. And then off the bat and output, I'm gonna jump the chain, deny check. So now anything coming in from the outside or anything going to the outside first is gonna go check and see Well, I have this in my list here. I need to delete this one. Iptables -d. So basically, first thing in the chain is gonna first thing in my output chain is gonna check with denied check. See if I'm in any of the denied list. And first thing in my input chain, it's gonna do the denied check. Okay, so now I can easily implement my blacklist and geoblocking in the chain, so I can in the same chain, and I can use this to expand it to other stuff that we'll see down the road. But for now, this is what we're gonna do. So if I try to access nslookup www.france.com, let's see, nslookup GeoIP lookup. Let's see, where is that? 146.185.43.107. This is France. So if I do curl http s 146 www.france.com, this should be getting blocked. 146.185.43.107. So iptables-mvl. Do iptables-s denied check. iptables-mvl denied check. I don't see anything matching. I see return to 000 all return. So this is the return traffic. Source any destination 168 return. Source 168.00 destination. It's gonna basically return. So this basically are those two are returning. So since my destination, so I have an issue with this line here. This is source 192.168 is basically bypassing, because my source is 192.168.00/16. So I need to move those down to the bottom. So iptables -save. Let's see, iptables rules.v4. So now I saved it. So iptables -s input that s denied check. So I see here this is source. This should be the return. The destination should be at the bottom after, because if my destination is, so I'm sourcing 1 and 2, so I'm returning after those. So I need to basically add this at the bottom, not at the top. So let's do that. So iptables -d deny check 1. I'm going to delete 1, 2, 3, 4, 5, 6. So I'm going to do it 6 times. 2, 3, 4, 5, 6. So if I do iptables -s deny check, now I see my Only thing is the geolocation block. So now I'm gonna basically make this append at the end, Iptables. So it's gonna check first the geolocation, and then it's gonna return to the calling chain. So now if I do curl friends.com, I should be getting blocked by geo IP blocking. So if I do tail-f var log iptables.log, I see it dropped at output geoblock outgoing. I see I'm getting blocked by the outgoing chain. But there is also another another thing that I have to bypass is at the end, basically add for source and destination 127.0.0.1. Add those to be allowed. So iptables dash append, basically to return to the calling chain. Then I check dash source 127.0.0.0/8 dash j return, and destination I'm gonna return to the calling chain. So now if I do iptable dash s deny check, basically I'm checking for geolocation and blacklist IPs for source and destination, and then returning for anything for my RFC 1918 or 127.0.0.8. Returning means it's gonna come back to the calling chain, which basically allows me to make this just to check for specific things, or the specific things are gonna be basically blacklist or geolocation. So now I can save that, and this is going to be part of my standard template for Iptables. This is how we can achieve geolocation blocking, and you basically simply append to this list if you have additional country you want to block, whether incoming or outgoing. You have the flexibility of doing that in this chain that you created.